There is a number that keeps appearing in the records, and nobody in the Southern Hemisphere can quite explain it. It shows up in blood bank registries, in university genetics papers, in the quiet notes of pathologists who work the overnight shifts in Darwin and Adelaide, and a town called Broken Hill that sits so far into the Australian outback it barely appears on most maps. The number is not dramatic on its own. It is a percentage, a modest one. But when you hold it up against what we know about human evolution, against the tens of thousands of years of migration that shaped this continent, against the ancient populations who have lived here longer than almost any other group of humans on Earth, that number stops making sense. It stops fitting the model. It becomes, if you are willing to sit with it long enough, one of the strangest biological puzzles the Southern Hemisphere has ever quietly produced. Australia has more Rh-negative blood than any country in the Southern Hemisphere. Not slightly more. Measurably, consistently, documentably more. And the people who study human blood for a living cannot fully agree on why. If you are watching this to fall asleep, that is exactly why I make these videos. The world has enough noise in it, enough urgency and brightness, and things demanding your attention right now. What I make instead are long, slow journeys into mysteries that do not need to be solved tonight. Things you can drift alongside, questions you can carry into sleep, and let your mind turn over in the dark. So maybe subscribe and let me know where you are right now and what time it is. I always check the comments, and there is something genuinely wonderful about seeing someone in Perth at midnight alongside someone in Toronto at 3 inches the afternoon. All of us gathered around the same quiet strangeness together. Because what we are going to explore tonight is genuinely strange. Australia is not where you would expect to find elevated Rh-negative frequencies. The science of how blood types spread across human populations points almost entirely toward ancient Europe, toward the cold mountain communities of the Basque country and the Celtic coastal fringe, toward populations that were geographically isolated for tens of thousands of years and preserved genetic patterns that migration erased almost everywhere else. The Southern Hemisphere, by most models, should tell a very different story. Africa, where modern humans evolved, has some of the lowest Rh-negative rates on Earth. Indigenous populations across South America, across Southeast Asia, across the Pacific Islands sit near zero. New Zealand, Papua New Guinea, parts of South Africa. All of them show the pattern you would expect from populations that carry the full ancestral heritage of Homo sapiens without the particular European genetic signature that seems to produce elevated Rh-negative frequencies. And then there is Australia. Australia, a continent settled by British colonists in 1788, yes, but also a continent with one of the oldest continuous human populations on the planet. A place where Indigenous Australians have lived for at least 65,000 years, and possibly much longer, making them the oldest civilization in the documented archaeological record by a margin that genuinely staggers the imagination. A place where convicts and free settlers and miners and gold rushers and soldiers and refugees have poured in from every corner of the world for more than 2 centuries, creating a genetic mixing that is unlike almost anything else in human history. When you measure the Rh-negative rate in Australia today, across the full contemporary population, the numbers are consistently higher than in Brazil, higher than in Argentina, higher than in South Africa, higher than in India, higher than in any other Southern Hemisphere nation with a comparable population size. The gap is not enormous. We are not talking about a difference of 20 percentage points. But it is consistent, it is reproducible, and it is old enough to show up in historical blood bank records that predate the age of genetic sequencing by decades. And the deeper you look, the stranger it gets. Because the story of Rh-negative blood in Australia is not a single story. It is several stories layered on top of each other, each one carrying its own set of questions that open into other questions. There is the story of the colonial population, the British and Irish settlers who arrived with higher baseline Rh-negative rates than almost any other European group. There is the story of the gold rush, which brought tens of thousands of people from across the world in one of the most chaotic and rapid demographic shifts any continent has ever experienced. There is the story of the indigenous populations, whose blood type data is incomplete in ways that raise serious ethical questions about who was measuring and why, and what they did with what they found. And underneath all of those stories, there is the oldest story of all, the one that begins not with colonization, but with the very first humans who ever set foot on Australian soil, tens of thousands of years before anyone had a word for blood type or a reason to ask the question. Tonight we are going to follow all of those threads. Not because we will find a clean answer at the end. We will not. The honest truth is that no one fully understands why Australia holds this particular biological distinction. But the search for understanding takes us through some of the most fascinating and underexplored territory in Australian history. Through the genetics of ancient migration, through the brutal arithmetic of colonial settlement, through the gold fields of Ballarat and the cattle stations of the Northern Territory, through the lives of women who nearly died in childbirth for reasons that doctors in the 19th century could not begin to explain, and through the quiet, meticulous work of researchers who are still today trying to map the full genetic history of a continent that has been home to human life for longer than almost anywhere else on Earth. So settle in. Let the room go quiet. There is no rush here. The mystery is old enough that it can afford to be told slowly. We begin not in Australia, but in the place where all human stories begin, Africa. Somewhere in Africa, roughly 300,000 years ago, the first anatomically modern human beings walked the earth. They had the same basic skull shape as you, the same capacity for language and abstract thought, the same brain architecture that would eventually produce fire-making techniques and burial rituals and cave paintings and eventually blood typing and genetic sequencing and sleep content on YouTube. They were, in every meaningful biological sense, us, just living at the beginning of a story that is still being written. For the first 200,000 years or so, modern humans stayed in Africa. The continent is vast and diverse, covering climates that range from equatorial rainforest to Mediterranean coast to the burning heart of the Sahara, and early populations moved and mixed across it in patterns we are only beginning to understand through ancient DNA analysis. What we know is that the Rh factor, the protein on the surface of red blood cells that divides the human population into positive and negative, existed in African populations at very low rates. The dominant pattern in sub-Saharan Africa is Rh positive, overwhelmingly so. Some studies of isolated indigenous African populations find Rh negative rates below 1%. Then around 70,000 years ago, something shifted. A group of modern humans, probably following the coastline of what is now the Arabian Peninsula, moved out of Africa. We do not know exactly how many of them there were. Genetic analysis suggests the founding population may have been surprisingly small, perhaps a few hundred individuals, perhaps a few thousand. But they carried with them the genetic raw material that would eventually populate the entire non-African world. These were your ancestors if you are not of exclusively sub-Saharan African descent. And some of what they carried in their genes, including the rare variant that produces Rh negative blood, would eventually find its way across every continent they touched. The first great destination was Australia. This is perhaps the fact that most reshapes how we think about Australian history. Before Europe, before the Middle East, before the Americas, the first great human migration out of Africa reached Australia. Genetic and archaeological evidence now suggests that the ancestors of modern Aboriginal Australians arrived on the continent at least 65,000 years ago, and some researchers put the figure closer to 80,000. To put that in perspective, modern humans did not reach Europe until roughly 45,000 years ago. The people who would become Aboriginal Australians were living on this continent for tens of thousands of years before the first human foot touched European soil. To get there, they crossed open ocean. Not a land bridge, not a narrow strait. Open ocean, at least 90 kilometers of it, even at the lowest sea levels of the last ice age. This means they had boats. Watercraft sophisticated enough to carry families across stretches of water where no land was visible. This is not primitive behavior. This is extraordinary navigation in an era when the entire rest of the human world had not yet figured out how to leave the African-Eurasian landmass, and they thrived. For 65,000 years, across ice ages and warming periods, across sea level changes that transformed the coastline of the continent dramatically, Through drought cycles and fire seasons and the extinction of megafauna that once shared the land with them, the ancestors of Aboriginal Australians endured. They developed what researchers now recognize as one of the most sophisticated bodies of ecological knowledge ever produced by any human civilization. Knowledge encoded in oral traditions and ceremony and the management of landscape through controlled burning. Knowledge so detailed and so deep that parts of it are still being incorporated into modern fire management and conservation practice. All of this before a single European ship appeared on the horizon. And when it comes to blood type, what those original Australians carried in their veins is a question that remains genuinely, uncomfortably incomplete. The blood typing of Aboriginal Australians is a topic that carries a weight of history that has nothing to do with genetics. When European researchers began systematically studying blood types in Indigenous populations throughout the 20th century, they were operating within a scientific culture that was also, simultaneously, engaged in practices we would now describe without hesitation as racist. Blood samples were collected from Indigenous communities, sometimes without meaningful consent, sometimes as part of broader anthropological studies that treated living people as specimens rather than as participants. The data that exists is therefore incomplete in ways that are not random. It is incomplete in specific, directed ways that reflect the priorities and the blind spots, and sometimes the outright prejudices of the people who collected it. What we do have suggests something genuinely interesting. The Rh-positive rate in many Aboriginal Australian populations appears to be very high, consistent with what you would expect from one of the earliest groups to diverge from the African founding population. But the data is patchy enough that firm conclusions are hard to draw. And some researchers have noted anomalies in specific communities, blood type patterns that do not fit neatly into any simple model of isolation and drift, that hint at a history of contact and mixture more complex than the standard narrative of 65,000 years of unbroken separation allows. We will come back to that. For now, hold it in mind as a thread we have not yet followed to its end. Because the story of Rh-negative blood in Australia is not primarily the story of Aboriginal Australians. It is, at its numerical core, the story of the people who arrived in 1788 and the centuries of immigration that followed. And that story begins with a fleet of 11 ships sailing into a harbour that the British called Botany Bay, carrying a cargo of human beings whose presence on this continent would reshape everything. The first fleet landed in January 1788. On board were roughly 1,500 people, of whom the majority were convicts. Men and women who had been sentenced to transportation for crimes ranging from theft of a handkerchief to serious violence, from political agitation to the kind of petty desperation that extreme poverty tends to produce. They came overwhelmingly from England and Ireland, with a scattering of other nationalities that the records show in smaller numbers. England and Ireland in the 18th century had Rh-negative rates that sat comfortably above the European average. The British Isles, particularly the Celtic fringe of Wales and Scotland and Ireland, had been the destination of Atlantic-facing populations for thousands of years, populations that some researchers believe carry some of the highest Rh-negative concentrations in the world. The reasons for this are debated, and we will explore them in depth later in this story. But the baseline fact is clear. The founding population of European Australia arrived with a genetic heritage that included elevated Rh-negative rates compared to most of the rest of the world. And then more people came. Many more. In the first decades of the colony, the population grew slowly and with enormous difficulty. The land was unfamiliar. The climate was unlike anything the settlers had experienced. The soil near Sydney Cove turned out to be poor for the kind of agriculture they knew. People starved, they struggled. Governors wrote desperate letters to London asking for more supplies, more skilled workers, more people who knew how to farm in conditions that were nothing like Kent or Cork or County Clare. The colony survived, but it survived through sheer stubbornness and through the labour of people who had no choice but to keep going. By the early 19th century, free settlers were beginning to arrive in larger numbers, attracted by land grants and the promise of a different life in a place where the old hierarchies might not apply quite so rigidly. These settlers too came primarily from the British Isles. From the west of England and from Ireland in particular, two regions where Rh-negative frequencies have historically been among the highest in the world. There is something worth pausing on here. Ireland specifically has one of the highest Rh-negative rates in Europe, somewhere between 25 and 27%, depending on the study and the specific population being measured. And the Irish were not a small presence in colonial Australia. They were a massive one. By some estimates, nearly a quarter of all convicts transported to Australia between 1788 and 1868 were Irish. Many of them were transported for political reasons, for resistance to British rule, for participation in the rebellions of 1798 and 1803 and 1848. They were young, many of them. They were healthy enough to survive the voyage, and they reproduced. The Irish contribution to Australian genetics has never been fully mapped. The records are incomplete in the way that records of poor and displaced people tend to be. But the demographic weight of that Irish founding population would have pushed the baseline Rh-negative rate of the colonial population meaningfully above the European average from the very beginning. And then gold was discovered. The 12th of February 1851, Edward Hargreaves, a prospector who had spent time in the California goldfields and came back to New South Wales with his eyes newly trained to read the landscape for signs of what lay beneath, found alluvial gold near Bathurst. Within weeks, the news had spread. Within months, the world had changed. The Australian gold rush was one of the most extraordinary demographic events of the 19th century. In 1850, the population of the Australian colonies was around 400,000 people. By 1860, it had more than tripled to over 1.1 million. People came from England and Ireland and Scotland and Wales. They came from China in numbers large enough to create entire Chinatown communities in goldfield towns that had not existed 5 years earlier. They came from the United States, veterans of the California rush who knew what they were doing. They came from Germany and Italy and Poland and the Caribbean and from parts of Africa. They came from everywhere. This was not orderly immigration. This was a human flood, fast and chaotic and ungovernable. The colonial authorities were overwhelmed. The goldfields became their own societies, with their own rules and hierarchies and tensions and occasional explosions, the most famous of which happened at a place called the Eureka Stockade in 1854, when miners, sick of corrupt policing and unfair licensing fees, built a barricade and raised a flag with a Southern Cross on a blue background and briefly declared that they had had enough. The genetic consequence of all this movement was a mixing that had no parallel in the Southern Hemisphere. Within a single generation, the Australian population went from being overwhelmingly British and Irish to being a complex blend of European nationalities with significant Chinese and smaller contributions from dozens of other groups. And the European component of that blend, the dominant one numerically, was still heavily weighted toward the British Isles, which meant still heavily weighted toward the populations with the highest Rh-negative rates in the world. By the time the gold rush subsided, Australia had not just found wealth in the ground. It had found a demographic identity that was unlike anything else in the Southern Hemisphere. A European settler population with a genetic ancestry dominated by two of the most Rh-negative groups in the world, the English and the Irish, mixed with a smaller but significant influx of other Europeans and a Chinese population whose Rh-negative rates were very low, which would have diluted rather than amplified the effect. The net result, if you were building a model, would be exactly what the blood bank records eventually showed. An Rh-negative rate in the Australian population that sits measurably above the Southern Hemisphere average. But models are not the whole story. And the blood bank records, when you start reading them carefully, reveal things that no model fully predicted. The first systematic blood typing in Australia happened in the 1920s and 1930s, in the aftermath of the First World War, when the medical community had begun to understand that blood transfusions could save lives but that getting the type wrong could kill. The Australian Red Cross established its first blood bank in 1929. The records from those early years are fragmentary, housed in archives in Sydney and Melbourne that have only recently begun to be digitized, but what they show aligns with what later More rigorous studies would confirm. The Rh-negative rate in the urban Australian population was consistently higher than researchers studying comparative global blood type distributions would have predicted from the demographic history alone. This is the part that makes the geneticists pause. You can account for most of the elevated Rh-negative rate through the British-Irish founding population and the patterns of subsequent immigration. The numbers mostly work. But when you look at specific regions of Australia, the story gets more complicated. The Northern Territory, for instance, shows patterns that researchers have noted but not fully explained. Some rural communities in South Australia show Rh blood type distributions that have puzzled the few people who have looked carefully at the data. And the question of what the full Indigenous Australian blood type picture looks like across all communities and all regions remains genuinely unanswered in ways that have nothing to do with genetics and everything to do with the history of who was doing the studying and who was being studied and what the power relationship between those two groups looked like. But let us stay for a moment with what the mainstream story tells us, because even the mainstream story is remarkable. To understand why Australia's Rh-negative rate is so notable, you need to understand what Rh-negative blood actually is and why it exists at all. Because on the face of it, Rh-negative blood should not exist in the frequencies it does. The biology makes it seem almost like a mistake. The Rh factor is a protein, a small one, sitting on the surface of red blood cells. If you have it, you are Rh positive. If you do not have it, you are Rh negative. Most people in the world are Rh positive. The protein is present. Blood cells carry it around without any fuss, the immune system ignores it, nothing interesting happens. But if you are Rh negative and you encounter Rh positive blood, your immune system notices something it has never seen before. It catalogs it. It builds a response. It creates antibodies. And those antibodies, once created, do not go away. They circulate indefinitely, ready to attack anything carrying that protein the next time it appears. For most purposes, this is a medical consideration rather than a daily reality. Blood transfusions have to be matched carefully, and they are. But there is one situation where this immune response becomes not just a medical consideration but a matter of life and death in ways that operated silently and invisibly through centuries of human history before anyone understood what was happening. Pregnancy. If an Rh-negative woman carries an Rh-positive baby, a small amount of the baby's blood can enter the mother's bloodstream during delivery. In a first pregnancy, this usually does not cause serious problems because the immune response takes time to develop and the baby is often born before the antibodies reach dangerous levels. But in a second or third pregnancy, if the mother has been sensitized, those antibodies cross the placenta. They enter the baby's bloodstream. They attack the baby's red blood cells, treating them as foreign invaders. The condition is called hemolytic disease of the newborn. Before modern medicine understood it, before the development of Rh immunoglobulin in the 1960s, it killed babies, not occasionally, regularly. In every generation of Rh-negative women who had Rh-positive partners, which in a mixed Rh-positive and Rh-negative population is statistically likely, some percentage of second and third children were born pale and swollen and barely alive, or did not survive at all. Mothers watched their later children die while their first child thrived, with no explanation that made sense, with no pattern anyone could see. In Australia specifically, this played out through the lives of thousands of women across the 19th and 20th centuries. Women who lost babies they could not explain losing. Women who were told by doctors who did not yet know that the cause was in their blood, that it was simply the way things were, that some children were not meant to live, that God's will was inscrutable and they should be grateful for the ones who survived. The records of this suffering are scattered through hospital registries and church burial books and the diaries of midwives who noted, sometimes with anguish, the pattern they could see but could not understand. In the isolated communities of the Australian interior, far from the hospitals of Sydney and Melbourne, where women gave birth attended only by neighbours or by Aboriginal community members who had their own healing traditions, the toll was likely higher than the records show. Because in isolated communities, there was no record at all. Children were born and died and were buried under eucalyptus trees, and the grief went unarchived. This is one of the reasons why the development of Rh immunoglobulin, the injection that prevents an Rh-negative mother from developing antibodies against Rh-positive fetal blood, is considered one of the most important medical advances of the 20th century. It was not dramatic. It did not cure a disease that already existed. It prevented a tragedy from happening in the first place. A single injection given after delivery or at 28 weeks of pregnancy, and the immune response is blocked before it can begin. In Australia, the rollout of Rh immunoglobulin in the late 1960s and early 1970s had a measurable effect on infant mortality statistics. The numbers that had been quietly elevated in certain categories, second and subsequent children, babies born to older mothers who had had multiple pregnancies, simply improved, not dramatically enough to make headlines, but enough that the researchers who were tracking them noticed and understood what it meant. And what it meant in part was that there had always been more Rh-negative women in Australia than anyone had formerly counted, because the disease only appears in Rh-negative mothers. And the fact that the disease had been occurring at the rate it had been, that the improvement in infant mortality was as significant as it was, implied a baseline Rh-negative population that was consistent with what the blood bank numbers were showing, more than any other country in the Southern Hemisphere. But why? Even granting the British-Irish founding population, even accounting for the gold rush demographics, even acknowledging the particular weight of Irish immigration in the convict era, the numbers sit slightly above where you would expect them to be. And when you start trying to explain that slight elevation, you find yourself pulled into the deeper mystery. The mystery that lies not in colonial history but in the far older question of where Rh-negative blood came from in the first place, and why it exists at all in a world where the evolutionary logic should have driven it toward extinction long ago. The evolutionary puzzle of Rh-negative blood is one of the genuinely interesting unsolved problems in human genetics, and to understand it, you need to go back to the beginning, not the beginning of Australia, the beginning of the trait itself. Somewhere, at some point in human prehistory, the gene responsible for the Rh protein was deleted, or inactivated, or mutated in a way that prevented the protein from being expressed on the surface of red blood cells. A single individual was born without the protein that every other primate on the planet carried. And something about that individual's life, or their descendants' lives, meant that the mutation was not simply lost in the noise of random genetic drift. It persisted. It spread. In some populations over thousands of years, it reached frequencies of 25%, 30%, even higher. This should not have happened. The pregnancy problem alone, the hemolytic disease that kills second and subsequent children of Rh-negative mothers with Rh-positive partners, should have been a powerful enough selection pressure to keep the frequency low. Every generation, a certain percentage of Rh-negative women would lose children to the immune incompatibility. Over thousands of generations, that should have been enough to gradually push the frequency down towards something approaching zero, but it did not. And in certain populations, it went the other way. It increased, which means either that Rh-negative blood confers some advantage that counterbalances the reproductive cost, some benefit we have not yet fully identified, or that the populations where it became common were isolated in ways that allowed random genetic drift to override the selection pressure, or both, operating at different times and in different proportions in different places. The populations where Rh-negative frequency is highest in the world are the Basque people of northern Spain and southern France, where rates reach 30 to 35%, and the populations of the Celtic fringe of Western Europe. The Irish, the Welsh, the Scottish Highlanders and Islanders, the Bretons of northwestern France. These are exactly the populations that contributed most heavily to the founding colonial population of Australia. And the Basque people and the Celtic populations have something in common beyond their elevated Rh-negative rates. They are among the most genetically isolated populations in Europe. The Basque language, Euskara, is a linguistic isolate unrelated to any other language on Earth. The Celtic populations of the Atlantic fringe maintained relative genetic isolation through most of the historical period. mountain communities and island communities and coastal communities that were harder to reach and therefore received less of the genetic mixing that reshaped the rest of Europe repeatedly. The medieval migrations, the Norse expansions, the movement of agricultural populations from the east, all of these waves of genetic change touched the Celtic fringe less thoroughly than they touched the continental interior. What this suggests is that the elevated Rh negative frequency in these populations is old. It predates the historical era. It predates agriculture. It goes back to something that happened in Western Europe in the deep prehistoric past, when the populations that would eventually become the Basques and the Celts were separated from other groups long enough, in small enough numbers, that a rare genetic variant could drift to unusually high frequency. And when those populations eventually settled Australia, they brought that frequency with them. Locked in their blood, carried across the ocean in convict ships and emigrant vessels and gold rush steamers, planted in a new continent where it would persist in their descendants for generations, showing up in blood bank records a century and a half later as a number that was slightly, consistently, measurably higher than any other country in the Southern Hemisphere. That is the mainstream story. It is a good story. It explains most of what the data shows. But it does not explain all of it, and the pieces it does not explain are the most interesting pieces. There is a researcher named Josephine Carroll who spent the better part of a decade in the 1970s and 1980s working through blood type data collected from communities across remote Australia. Carroll was not famous. She did not publish in the journals that attracted the most attention. She worked mostly in collaboration with public health nurses who travelled to communities in the Northern Territory and the Western Desert and the far north of Queensland, and she gathered data the slow way, one sample at a time, in communities that had had almost no previous contact with the kind of systematic health surveys that urban populations took for granted. Her findings were never fully published. Some of her notes exist in the archive of a university in Adelaide. A few of her conclusions were cited in passing in a paper published in 1989 about blood type distributions in the Pacific region. But the picture she assembled over those years was complicated enough, and the context in which it had been assembled was sensitive enough, that she was cautious about drawing firm conclusions. What she wrote in a letter to a colleague, a letter that was recently found in that same archive and quoted in a 2019 paper on Australian blood type history, was this: "The distribution of blood types in this population does not match what I expected to find given the established models. There are communities where the frequencies suggest contact and mixture that the historical record does not account for. I do not know what to make of this yet. I may never know." The established models she referred to were the models built on the assumption that Aboriginal Australians had been genetically isolated from the rest of the world for 65,000 years. Those models were the scientific consensus at the time. They made sense of a lot of the data, but they also, as it turned out, left some things out. Because Aboriginal Australians were not, in fact, completely isolated for the entire 65,000 years of their presence on the continent. We know this now with a confidence that was not available to researchers in the 1980s, because we now have ancient DNA analysis tools that simply did not exist then. And what the ancient DNA data shows is that Australian prehistory was more complicated than the isolation model suggested. Roughly 4,000 years ago, there is a clear genetic signal in Aboriginal Australian DNA of a new population arriving. The signal includes a genetic variant associated with the dingo, the wild dog that is Australia's apex non-human predator, which was not native to Australia and which almost certainly arrived with humans from somewhere in southern Asia. The dingo shows up in the archaeological record around 3,500 years ago. The DNA shows the same signal. And accompanying both the dingo and the new genetic markers is something else. New stone tool technologies that appear in the archaeological record at roughly the same time, representing what researchers call the Australian small tool tradition. None of this is simple. None of it is fully understood. But it means that 4,000 years ago, people arrived in Australia from somewhere outside the continent, mixed genetically with the existing population, and left markers that are still detectable in the DNA of living Aboriginal Australians today. Who these people were, exactly where they came from, and what happened to them over the following millennia is a question that Aboriginal communities themselves have strong interests in, and their perspectives are not uniform. Some see the outside contact as consistent with their own oral traditions about relationships with neighboring peoples. Others are more cautious about interpretations that could be used to undermine land rights arguments or other political claims. The point for our purposes is simpler. The story of what blood runs in Australian veins is not a story with two clean chapters, Aboriginal Australia and European Australia, divided by 1788. It is a story with multiple chapters, some of which are still being written, and some of which may never be fully legible because the evidence has been lost or has never been systematically collected. And somewhere in that complexity, in those layers of contact and mixture and isolation and migration that stretch back tens of thousands of years, is the fuller explanation for why Australia's blood type profile looks the way it does. Let us follow one more thread before we move deeper into the colonial history. Because there is a question about the Rh factor specifically, not about general blood type distributions, that hangs over this entire story, and that researchers have been circling for decades without quite landing on an answer. The question is this: why does the Rh negative trait exist at frequencies high enough to matter in populations that had no documented contact with the European populations where the highest frequencies are found? Because it does, in small but measurable numbers. There are Rh negative individuals in populations where the standard model says there should be essentially none. Indigenous groups in Australia, Indigenous groups in parts of Southeast Asia, communities in Africa that are geographically isolated enough that the standard explanation of admixture with European colonizers does not work. These cases are rare. They are outliers. They are the kind of data point that is easy to dismiss as measurement error or contamination or some artifact of the sampling process, and sometimes that is exactly what they are. Blood type data collected in field conditions under difficult circumstances is not always clean. But the researchers who have spent the most time with this data, the ones who have gone back and checked and rechecked and tried to rule out the alternative explanations, some of them have come to the conclusion that these outliers are real, that there are individuals in populations where Rh negative blood should theoretically be absent who nonetheless carry the Rh negative genotype. And that this suggests either that the mutation happened more than once, independently, in different populations, which is genetically possible though unlikely, or that there were contact events between populations that the historical record does not fully capture, or that we are missing something fundamental about how and when and where this particular genetic variant emerged. None of those options is simple. None of them fits neatly into any existing model. They sit at the edge of what the data can tell us, in that uncomfortable territory where the honest answer is we do not know, and anyone who tells you they do is overreaching. This is the territory where the most interesting science happens. And also, if you are not careful, the territory where the most irresponsible speculation happens. The history of Rh negative blood is unfortunately rich in irresponsible speculation. The online world is full of claims about Rh negative people being descended from aliens, from angels, from the survivors of Atlantis, from a race of beings who arrived on Earth from somewhere else and left their genetic trace in the minority of humans who carry negative blood. These claims are not science. They are mythology dressed in the language of science, which is more dangerous than plain mythology because it is harder to identify at a glance. But here is what is also true. The legitimate scientific mystery at the center of Rh negative blood is strange enough and old enough and deep enough that you do not need any alien intervention to find it genuinely astonishing. The real story is astonishing on its own terms. And in Australia specifically, the real story has layers and textures that the mythology completely misses, because the mythology has no interest in colonial history or convict ships or the quiet suffering of women who lost babies they could not explain losing. The real story has all of that, and more. Let us go back to the land itself for a moment, because Australia is not just a place where these patterns play out. It is a place that has a particular relationship with blood, with survival, with the deep human experience of being in a body in an environment that is trying to kill you. The Australian continent is ancient in a way that most of the rest of the world is not. The rocks of the Pilbara in Western Australia are among the oldest exposed rocks on Earth, dated to over 3 billion years. The landscape has a stillness to it that visitors consistently remark on, a geological patience that is unlike the active, churning, earthquake-prone geologies of younger continents. The desert interior is vast and merciless and beautiful, and it has been home to human life for so long that the concept of wilderness does not quite apply. When Aboriginal people say that the land is alive, they are not speaking metaphorically about the way a city person might romanticize a walk in the park. They are describing a relationship with a place that has been cultivated and maintained and negotiated across thousands of human generations. And those thousands of generations left something in the land, not always visible, not always legible to eyes trained by other traditions. But there in the rock art of the Kimberley and the Arnhem Land escarpment, in the songlines that crisscross the continent, encoding geographic knowledge in melody and narrative, in the management of water sources and fire regimes that kept the landscape productive through climatic variations that would have destroyed less sophisticated systems of knowledge. There, in all of that, is the evidence of a civilization that is older than any other on Earth by a margin that keeps growing as the archaeological dating techniques improve. And what we are still trying to understand is how that ancient civilization, those 65,000 years of human presence, relates to the other layers of Australian history. The 4,000-year-old contact signal, the colonial period, the gold rush, the 20th century immigration waves that brought people from Italy and Greece and Vietnam and Lebanon and India and China and every other corner of the world. All of those layers sit on top of each other, and the blood that flows through the veins of Australians today is the product of all of them, in proportions that vary by community and by family, and by the particular accidents of who met whom and had children together, and whose descendants stayed in Australia and whose left. The Rh negative frequency that makes Australia distinctive in the Southern Hemisphere is a product of all those layers too, primarily of the British-Irish colonial layer, statistically, but touched and shaped by the others in ways that are harder to measure and easier to miss. There is something worth sitting with in that complexity. In the idea that a single number in a blood bank registry, a percentage on a typed report in an archive in Adelaide or Melbourne or Darwin, is actually the compression of an enormous and intricate and still only partially told human story. A story that begins in Africa 70,000 years ago and passes through an ocean crossing and 65,000 years of island life and a contact event 4,000 years ago and 11 convict ships and the gold fields of Ballarat and the cattle stations of the territory and the immigration halls of the post-war period and arrives, finally, at today, at you, wherever you are, whatever time it is, listening in the dark. You carry a story in your blood too. Everyone does. And the story Australia carries is longer and stranger and more layered than almost anywhere else on Earth. That is why this particular mystery is worth spending a night with. Now let us go further into it. There is a town in South Australia called Kapunda that very few people outside Australia have ever heard of, and that most Australians know only as the site of an old copper mine and a slightly famous statue of a ram. But Kapunda has a place in this story because it was one of the first significant destinations for a wave of German immigration that reshaped a particular corner of Australian genetics in the mid-19th century, and that has never been fully accounted for in the popular telling of Australian blood type history. The German settlers who arrived in South Australia from the 1840s onward came primarily from Silesia and Prussia and the wine-growing regions of Württemberg. They were fleeing a combination of economic hardship and religious persecution. Many of them were Lutheran, and the South Australian colony, which had been established explicitly with religious freedom as one of its founding principles, offered them something they could not find at home: land, independence, the freedom to worship as they chose. They settled the Barossa Valley, which would eventually become one of the most famous wine regions in the world. They settled the Adelaide Hills. They settled the Fleurieu Peninsula and the north of the state. They built churches that looked like the churches of Saxony, with steep roofs and rendered stone walls, and they maintained their language and their customs for generations in a way that was distinctive even in the diverse world of 19th century colonial Australia. German blood type distributions are different from British blood type distributions. The Rh negative rate in Germany sits close to the European average, around 15%, lower than the Irish and British rates that dominated the rest of the Australian population. The German settlement of South Australia was large enough and concentrated enough to have measurably affected the blood type statistics of that state, compared to New South Wales and Victoria, where the British-Irish influence was more dominant. This is the kind of detail that gets lost when you are talking about Australia as a single entity. The country is enormous. It is almost as large as the continental United States. And the different waves of settlement landed in different places and mixed in different proportions and produced regional genetic profiles that are meaningfully distinct from each other, even if the national average tells one story. South Australia's Rh negative rate, when studied separately from the national figure, sits slightly lower than the national average, which tracks with the higher proportion of German ancestry in that population. New South Wales and Victoria, where Irish and British ancestry is most dominant, tend to track slightly higher. Queensland has its own story, involving a significant history of South Sea Islander labour in the sugarcane fields of the 19th century, a population that was almost entirely Rh positive, and the particular demographic patterns of Northern European settlement that occurred in different proportions than in the South. Western Australia, which had a later and somewhat different settlement history, including its own gold rush centred on Kalgoorlie in the 1890s, has its own regional profile. Tasmania is perhaps the most interesting case for blood type researchers, because Tasmania's European population has a founding bottleneck that is unusually well documented. The Tasmanian Aboriginal population was catastrophically reduced through a combination of disease, violence, and forced relocation in the early decades of colonisation. The full population was relocated to Flinders Island by the 1830s, and the last person who had been born a fully tribal Tasmanian Aboriginal died in 1876. The story of that population and its descendants, because there were descendants through mixed relationships, is complicated and painful, and still being worked through by the Tasmanian Aboriginal community today. The European population of Tasmania was established early and grew relatively slowly. It had a high proportion of convict ancestry, which meant a high proportion of British and Irish ancestry, which meant a relatively high baseline Rh negative rate. And because Tasmania is an island, separated from the mainland, it retained that founding genetic signature more strongly than the states that experienced the more chaotic mixing of the gold rush and the later immigration waves. Tasmanian blood type data from the mid-20th century shows one of the highest Rh negative rates in any Australian state. Some researchers have noted this as consistent with the bottleneck effect of a founding population that was heavily weighted toward high Rh negative British and Irish ancestry, and then grew in relative isolation from the genetic mixing that reshaped the mainland population over the following century. But here too, there are anomalies. Data that does not quite fit, numbers in specific communities that are hard to explain with the standard model. And the question that researchers in this space always eventually arrive at, the question that Carol was circling in her letter from the 1980s, is whether the anomalies are real or whether they are artifacts of the collection process. Because this is the fundamental epistemological problem with the study of blood type distributions in historical populations. The data is never perfect. It is collected under specific conditions by people with specific purposes, from populations that are never fully representative. In the early days of blood typing, hospitals collected data only from people who came to hospitals. In rural and remote Australia in the early 20th century, coming to a hospital required a level of access, physical and financial and social, that many people did not have. The blood type data that exists from that era is therefore biased toward urban, better off, and more recently arrived populations. It systematically underrepresents the people who were most isolated, most disadvantaged, and in many cases most interesting from a genetic history perspective. The systematic study of Indigenous Australian blood types that Carol attempted in the 1970s and 1980s was trying to fill in part of that gap, but it ran into its own problems. The communities she was working with had complex relationships with the research process itself. There had been a long history of researchers arriving, collecting samples or data, and then disappearing back to their universities to publish findings that the community never saw and never benefited from. The communities were understandably cautious. The consent processes of the time were not adequate by contemporary standards, and some of the data that was collected was stored in ways that made it difficult to use later, because the context in which it had been collected was not fully documented. What we are left with, in 2024, is a picture that is clear in its broad outlines and genuinely murky in its details. Australia's Rh-negative rate is demonstrably higher than any other Southern Hemisphere country. The primary explanation is the British-Irish founding population. But the full story is layered in ways that no single explanation captures, and some of the layers are currently inaccessible, locked in archives that have not been fully catalogued, or in communities that have not yet determined how much of their genetic information they want to share with the wider world, or in the ground itself, in ancient DNA that has not yet been extracted from the right burial sites with the right level of care and consent. The mystery is real, and it is old, and it is worth sitting with in the dark. There is something else that is worth following here, something that takes us away from the statistics and into something more personal. Into the lives of the women whose bodies were at the center of this story for generations, long before anyone understood what was happening in their blood. The history of maternal mortality in Australia is a history that has been systematically underwritten. The women who died in childbirth, or who watched their children die in the remote communities of 19th and early 20th century Australia, were not the women whose names appear in the history books. They were settlers' wives and station hands' partners, and Aboriginal women whose names were never recorded at all. Their deaths and their losses were folded into statistics that gestured at the general difficulty of life in a new and unfamiliar country, without distinguishing between the deaths that were caused by inadequate sanitation and the deaths that were caused by inadequate nutrition and the deaths that were caused by the invisible incompatibility in their blood. But some of those deaths, some percentage of them that we cannot now determine precisely, were the direct consequence of Rh incompatibility. Were the consequence of Rh-negative women having Rh-positive partners in second and third and fourth pregnancies? Were the consequence of a biological mechanism that nobody in the world understood until the 20th century. And in Australia, with its elevated Rh-negative rate, the toll was higher than it would have been in most other places in the Southern Hemisphere. This is not a comfortable thing to sit with. The idea that a genetic characteristic that defines a population, a characteristic that was shaped by migration patterns and colonial history and the particular accidents of who went where and why, translated directly into the suffering and death of women and children whose names are mostly lost. It connects the abstract world of blood type statistics to the lived experience of real people in ways that make the statistics feel very different. It is also, in a quiet way, part of why the development of Rh immunoglobulin in the 1960s was such a profound medical achievement, not just because it saved lives in a general sense, because it ended a specific, genetically determined suffering that had been playing out in Australian families for almost 2 centuries, that had been playing out in European families for thousands of years before the colonization of Australia, and that had gone unrecognized, unnamed, and unmourned for all of that time. The women who suffered from this, who lost babies to it, did not know they were part of a genetic story. They did not know that their blood type was elevated by the accident of being Irish or Welsh or the descendants of people who had lived in the mountains of Western Europe for thousands of years in relative isolation. They knew only the specific grief of a specific loss, the weight of a child who did not survive, the confusion of a body that seemed to turn against what it was supposed to protect. That grief is part of this story too. It belongs in this telling. Let us move now into a different kind of mystery, one that sits at the border between genetics and something harder to categorize. Because the story of Rh-negative blood in Australia is not only a story told in hospital records and blood bank registries and academic papers, It is also a story told in the culture, in the particular way that certain ideas about blood and ancestry and identity have circulated through Australian communities in ways that are specific to this country's history. Australia has a complicated relationship with the concept of bloodline. This is inevitable given its colonial history, given the explicit ideologies of racial hierarchy that shaped the early colonial period and that found their most infamous expression in the policies of the Stolen Generations, in which Aboriginal and Torres Strait Islander children of mixed descent were forcibly removed from their families and placed with white families, in the explicit belief that their Aboriginal ancestry could be bred out over generations. These policies operated from the late 19th century through to the 1970s. They caused trauma that persists today in Australian Indigenous communities and families. And they were built on a theory of blood, of racial essence carried in the blood that was pseudoscientific and that has been repudiated by every legitimate branch of modern genetics. The concept of blood quantum, the idea that a person's racial identity could be measured in fractions based on how many of their ancestors belong to which category, was used in Australia as a tool of social control and of what some historians have called cultural genocide. It took the metaphor of blood as identity and weaponized it, turning something that should have been a matter of community belonging and lived culture into a bureaucratic calculation that determined where you could live and who you could marry and what rights you had. This history makes it necessary to be very careful about how we talk about blood type and identity. There is a significant difference between the scientific observation that certain blood type frequencies cluster in populations that share a common geographic and genetic ancestry, which is real and measurable and interesting, and the claim that blood type or any other genetic characteristic determines who a person is, what their identity is, or what rights they have. The first is science. The second is ideology. And Australia's history contains a particularly painful example of what happens when ideology is dressed in the language of science and applied to living people. With that context firmly in place, we can look at how the conversation about Rh-negative blood has operated in Australian popular culture, because that conversation is interesting in its own right, separate from the scientific questions and separate from the historical ones. Australia has, for at least the past 2 decades, had a subculture of interest in Rh-negative blood that mirrors and in some ways amplifies the global phenomenon. The online communities that have grown up around Rh-negative identity, the forums and Facebook groups and YouTube channels that collect and circulate claims about the special properties of Rh-negative blood, the heightened sensitivity and unusual abilities and alleged extraterrestrial ancestry of Rh-negative individuals, these communities have active Australian nodes. And the Australian discussions have particular textures that are not present in the same way in the American or British versions. There is an Australian tendency to take the mystery in a specifically local direction, to connect Rh-negative blood not to abstract claims about alien seeding of the human population, but to questions about the deep history of the continent itself, about what might have happened in those 65,000 years of Aboriginal Australian civilization before the colonial period, about the anomalous data points in Carroll's work, about the contact signals in the ancient DNA record, about the possibility that the Australian story contains some piece of the puzzle about where Rh-negative blood came from that the European-focused models have missed. This is, to be clear, speculation. The evidence does not currently support any specific theory about a unique Australian origin for Rh-negative blood or any special relationship between the continent's ancient history and the distribution of the trait in its current population. But the speculation is interesting as a cultural phenomenon because it reflects something real about how Australians relate to the mystery of their own continent. There is a hunger in Australian culture for stories that take the continent seriously as a place of deep time and ancient mystery, that push back against the colonial tendency to treat Australian history as beginning in 1788. And Rh-negative blood, with its genuine biological mystery and its connections to questions about ancient populations and migrations, has become one of the vehicles for that hunger. Some of what circulates in these communities is harmless and sometimes genuinely interesting speculation. Some of it is directly harmful misinformation, claims about Aboriginal blood types that are not supported by any evidence, and that can easily shade into the same pseudoscientific racial thinking that underpinned the colonial policies we were just discussing. The line between curiosity and appropriation, between genuine historical inquiry and the use of Indigenous history as a vehicle for non-Indigenous fantasies, is not always easy to maintain in these communities, and it is not always maintained. But underneath the misinformation and the mythology, there is a real question. And the real question is worth pursuing on its own terms, with the kind of care and rigor and epistemic humility that the mainstream scientific conversation brings to it, even when that conversation is slower and less dramatic than the online speculation. The real question is about deep time, about what a continent can tell us about human history when it has been home to our species for longer than almost anywhere else on Earth, about whether the genetic patterns we observe in Australia today carry information about events that happened long before the colonial period, and if so, what that information might mean. The answer, right now, is that we do not fully know. The tools are getting better. The ancient DNA work is progressing. The ethical frameworks for working with Indigenous communities on genetic research questions are improving, slowly and with genuine difficulty, but improving. The picture that will emerge over the next decade or two is going to be more complete and more nuanced than the one we have today, and it will almost certainly contain surprises. Because Australian prehistory has already delivered multiple surprises in the last 20 years, each one requiring a revision of what we thought we knew about the continent's human history. The 4,000-year-old contact signal, the Denisovan ancestry that shows up in some Aboriginal Australian genomes, the mounting evidence that the first Australians were not a single population but a diverse set of groups that arrived at different times and mixed and diverged and mixed again over tens of thousands of years. Each of these discoveries has changed the story, and each of them has implications for the blood type question that have not yet been fully worked out. This is the frontier. This is where the science sits right now, not at the level of a settled explanation, but at the level of a partially illuminated map, with large sections still marked with the cartographer's traditional phrase for the unknown, "Here there be dragons." Or rather, here there be questions that might turn out to be even more interesting than dragons. Let us go further into the historical record, into the specific lives of specific people who carried this blood through the history of the continent. Because the story of Rh-negative blood in Australia is ultimately a story about people, and the people are more interesting than the statistics. One of those people was a woman named Margaret Hennessy, who arrived in Australia on a transport ship called the John Barry in 1840. She was 22 years old, Irish, sentenced to 7 years transportation for theft. The records describe her as 5 feet 2 inches tall, with dark hair and grey eyes, which is the kind of detail that appears in the transportation records, because the colonial authorities wanted to be able to identify their convicts if they escaped. She was from County Galway. Margaret Hennessy survived her sentence. She married a free settler named Thomas Walsh in 1845 in a small Catholic church in the Hunter Valley of New South Wales that no longer exists. She had 7 children. 3 of them died in infancy or early childhood. One of those children, a boy named Patrick, who was born in 1851 and died 3 weeks later, was described in the church burial record as having been born weak and having failed to thrive. Whether Patrick Walsh died of Rh incompatibility, we cannot know. The term did not exist. The mechanism was not understood. He is one entry in a list of entries in a ledger that was written by a priest in a language he had learned in County Mayo and practiced for the rest of his life in a country that his home country had shipped him to involuntarily. He is a data point in a story that he would not have recognized as being about him. But if Margaret Hennessy was Rh negative, which statistically speaking, given her Irish origins, she had roughly a 1 in 4 chance of being, and if Thomas Walsh was Rh positive, which statistically he had roughly an 85% chance of being, then the immune response that may have killed Patrick Walsh was a consequence of the same genetic history that put his mother on a transport ship in the first place, was a consequence, ultimately, of the particular isolation of the Western Irish population over centuries of geographic and social marginalization.
Of the same forces that produced elevated Rh-negative rates in Celtic Atlantic populations, of the same deep European history that is still playing out, generations later, in the blood bank statistics of a country that Margaret Hennessy never chose to come to. There is no monument to Margaret Hennessy. There are thousands of people like her, whose names are in the transportation records and the church ledgers and nowhere else, who carried this blood through this history without understanding what they carried, who paid the price of it in grief they could not explain, and who nonetheless survived and had children and contributed to the genetic fabric of a continent that is still being understood. Their story is part of the story of why Australia is where it is in the Southern Hemisphere blood type tables, not the whole story, but a part of it that gets lost when you read the numbers without thinking about the lives behind them. That is what this kind of history requires. The willingness to hold the numbers and the lives together, to let each one inform the other, to resist the temptation to reduce either one to a simplified version of itself. The numbers are real. The lives are real. The mystery is real. And we are still in the middle of it. There is a place in the Northern Territory called Tennant Creek that sits roughly in the middle of the Australian continent, which means it sits in one of the most remote locations a person can find in a developed country. The nearest city of any size is Darwin, about 1,000 kilometers to the north. Alice Springs is about 500 kilometers to the south. The town itself has a population of around 3,000 people, and it sits in a landscape that is red and ancient and vast, and that has been home to the Warramungu people for tens of thousands of years. In the 1980s, Tennant Creek became the site of one of the more unusual incidents in Australian medical history, which was in itself part of a larger and more complicated story about the delivery of healthcare to remote Indigenous communities across the country. The incident involved blood transfusions. A group of patients at the Tennant Creek Hospital, all of them Aboriginal, received transfusions as part of emergency treatment for various conditions. Several of these patients experienced transfusion reactions, some of them serious. The reactions triggered an internal investigation that revealed something the hospital had not previously formally acknowledged. The blood type testing protocols being applied in remote Northern Territory hospitals were not as rigorous as those applied in urban hospitals in the south. The assumption, implicit rather than explicit, had been that the Aboriginal patients being treated at remote hospitals were very likely to be Rh positive, consistent with the expectation for populations without significant European admixture, and the screening procedures had not been designed to catch the cases where that assumption was wrong. The investigation found that there were Rh negative individuals in the community who had been incompletely screened, and it raised the question that Carol had been circling. If the model said there should be essentially no Rh negative blood in this population, and there was, where had it come from? The answers that the investigation arrived at were not dramatic. Some of the Rh negative individuals had mixed European ancestry that the medical intake process had not documented, because the forms being used did not ask the right questions, and because the social context made it complicated for individuals to self-identify in ways that might have flagged the relevant history. This was a common problem in healthcare delivery to Aboriginal communities in the Northern Territory at the time, and in some respects continues to be. The medical system was designed by and for a population whose genetics and history differed from the population it was serving in remote communities, and the gaps in that design had real consequences. But some of the cases did not fit that explanation as cleanly. Some of the Rh negative individuals in those communities had family histories that the investigators could trace, and that did not include the European admixture they were looking for. These cases were noted. They were flagged as requiring further investigation. And then, as happens with investigation reports in bureaucratic systems that are stretched thin, the follow-up did not happen, or happened in an incomplete way, or happened, and the results were filed somewhere that subsequent researchers could not find. What this incident illustrates is the gap between the theoretical model and the empirical reality of blood type distributions in remote Australia. The model is built on assumptions about which populations carry which genes in which proportions. Those assumptions are reasonable at the level of the population as a whole. But at the level of individual communities, and particularly at the level of communities whose histories include multiple waves of contact and mixture that the historical record does not fully capture, The model is an approximation, a useful one, but an approximation. And approximations in medicine can have consequences that abstractions do not. The blood typing protocols in Australian remote healthcare have improved significantly since the 1980s. The Australian Red Cross Blood Service, which is responsible for blood safety nationally, has worked with remote healthcare providers to develop protocols that do not rely on population-level assumptions about blood type distributions. Every patient is now typed individually before receiving a transfusion. The old assumption that remote Aboriginal patients could be treated as statistically very likely to be Rh positive is no longer part of clinical practice. But the incident, and the question it raised about the actual blood type distribution in remote communities, continues to sit in the background of Australian blood type research, not as a settled matter but as a thread that has not been fully followed. There is something else that happened in the Northern Territory that connects to this story in a different way. Something that takes us not into the medical system but into the landscape itself, into the way that the Australian interior has preserved things that the rest of the world has lost. In the region around Lake Eyre, which is now called Katithanda Lake Eyre in recognition of the Arabana people's name for it, there are rock art sites that are among the oldest in Australia. Some of the art dates to tens of thousands of years ago, though the exact ages are difficult to establish with current dating methods. The subjects of the art include animals, many of them extinct, which allows archaeologists to establish minimum ages based on when those species disappeared. And among the images are hands, stenciled hands, made by the same technique used in the cave art of Europe, pressing a hand to the rock and blowing pigment around it. The hands in the rock art of Central Australia are not identical to the hands in the cave art of France and Spain. They are made differently, using different pigments and different techniques, and they are in a different hemisphere on a different continent, separated by tens of thousands of years of divergent cultural development. But they are the same impulse. The same human need to say, I was here, I existed, remember me. When you think about blood type in the context of those hand stencils, something shifts. The hands belong to people who were here 40,000 years ago, or 30,000 years ago, or whatever age the specific site dates to. Those people had blood types. They had the same basic distribution of ABO antigens and Rh factors that human populations carry. And because they were among the first modern humans outside Africa, because they were the descendants of the earliest exodus and had been living on this continent since a time when the rest of the human world was still being settled, they may well have carried genetic patterns that were different from what developed independently in Europe over the same period of time. Whether those patterns included any meaningful frequency of Rh-negative blood is currently unknown. The DNA that would be needed to answer the question has largely not survived in Australian conditions. The country's climate, particularly the hot, humid conditions of the tropical north and the acidic soils of much of the continent, is not favourable to the preservation of ancient DNA over the kind of timescales we are talking about. The ancient DNA work that has been done in Australia is fragmentary and geographically limited, but the question is real. And the possibility that the full story of Rh-negative blood in Australia involves not just the colonial European layer but some echo of the continent's deep human history is not crazy. It is not supported by current evidence. But it is not contradicted by it either. It sits in the space of the genuinely unknown, alongside the other unanswered questions that make Australian prehistory one of the most fascinating and most underexplored frontiers in the study of human history. And it sits next to those hand stencils in the rock, in the presence of people who were living here before Europe had any humans in it at all. In the presence of a story so old that our normal categories of ancient and modern stop quite applying. Let the mind rest there for a moment, in the enormity of it. There are hands on rocks in Central Australia that were placed there before the last ice age, before the cave paintings of Lascaux. Before the first modern humans set foot in Europe, the people who placed those hands were fully human. They had language and culture and social organization and the full range of human emotion. They also had blood types that we do not know and may never be able to determine with the precision we would like. They are part of the Australian blood type story. Even if we cannot read their contribution clearly, even if the record is incomplete and the evidence is fragmentary, and the full picture remains beyond our reach. They were here, and they left their hands on the stone, and the stone remembered. Now, let us move into the period that reshaped everything. The period that is simultaneously the most documented and the most complicated layer of Australian blood type history. The 20th century, when the science of blood typing actually existed, when the records were systematically kept, and when Australia became not just a place where these patterns were present, but a place where the medical consequences of those patterns were recognized, treated, and eventually understood in ways that changed the lives of women across the entire country. This is the part of the story where the mystery becomes medicine, where the abstract question of why certain blood types are more common in certain populations meets the very concrete question of what to do about it, and where Australia, with its elevated Rh negative rate, found itself at the center of a problem it had been living with for almost 2 centuries without knowing it. The recognition of Rh incompatibility as a medical problem began in Australia in the 1940s and 1950s, when the discovery of the Rh factor by Landsteiner and Wiener in 1940 finally gave doctors a framework for understanding what had been killing babies for generations. The Australian medical community was not at the leading edge of this research. The key work was done in Britain and the United States, but Australian hospitals and Australian public health departments moved relatively quickly to incorporate the new understanding into clinical practice, and the particular demographic characteristics of the Australian population meant that the scale of the problem was, in some respects, larger here than in many comparable countries. The Australian Red Cross Blood Service began systematic Rh testing in the late 1940s. The records from those early years of testing reveal a population whose Rh negative rate was consistently and measurably higher than the rates being recorded in comparable studies in New Zealand, South Africa, and the other English-speaking countries of the Southern Hemisphere. This was the first systematic documentation of what the transportation records and the immigration patterns had implied for a century. Australia had more Rh negative blood than anywhere else in the Southern Hemisphere. The blood bank data made it quantifiable for the first time. The practical consequences of this were significant. With a higher proportion of the female population being Rh negative, the number of pregnancies affected by Rh incompatibility was correspondingly higher. The number of babies being born with hemolytic disease of the newborn was higher. The number of women requiring careful obstetric management because of their Rh status was higher. And in a country where significant portions of the population lived in remote areas far from major hospitals, the ability to provide that careful management was limited. Australian obstetricians in the 1950s and 1960s were dealing with a problem that was better understood than it had ever been before, but that was still, in the absence of an effective preventive treatment, manageable only through monitoring and intervention after the damage had already begun. The exchange transfusion technique, in which a newborn's entire blood supply was replaced to remove the maternal antibodies attacking it, had been developed and was being used. But it was a drastic intervention, available only in hospitals with the necessary equipment and expertise, which meant it was largely unavailable in the remote communities where the need was sometimes greatest. This is the quiet tragedy at the heart of the 20th century chapter of Australian blood type history. The science had advanced far enough to understand the problem, but not yet far enough to prevent it. The gap between understanding and solution was still claiming lives, still causing the same grief that Margaret Hennessy and women like her had experienced a century earlier, but now, with the additional cruelty of occurring in an era when doctors understood what was happening and still could not fully stop it. The development of Rh immunoglobulin, the anti-D injection as it is known in Australia, changed this. The clinical trials that established its effectiveness were conducted primarily in the United States and Britain in the mid-1960s. Australian researchers were among those who contributed to the trials, and Australian obstetricians were early adopters of the treatment once it was approved. But there was a production problem that had a specifically Australian dimension. Rh immunoglobulin is derived from the plasma of Rh-negative individuals who have been exposed to Rh-positive blood and have developed high levels of the relevant antibodies. In other words, to make the treatment that prevents Rh incompatibility from harming babies, you need plasma donors who are themselves Rh negative and have been sensitized. And the more Rh negative your population, the more potential plasma donors you have. Australia's elevated Rh negative rate meant that the country was well positioned to develop a domestic supply of Rh immunoglobulin, and in the 1960s and 1970s, that is exactly what happened. Australian researchers and the Australian Red Cross worked to establish a domestic plasma collection program using Rh negative donors who had been intentionally immunized with their consent by exposure to small amounts of Rh positive blood. These donors, many of them men who volunteered specifically for this program because they wanted to contribute to solving a problem they had seen affect women in their lives, became the foundation of the Australian anti-D supply. This is an unusual piece of Australian medical history that has not received much public attention. The fact that the country's elevated Rh negative rate, which was itself a consequence of the colonial history that began in 1788, made Australia particularly well suited to produce the treatment that would end the suffering that the elevated Rh negative rate had been causing for 2 centuries. There is something almost symmetrical about it. Not a comfortable symmetry, because the suffering was real and the deaths were real and the grief was real, but a symmetry of a kind that history sometimes produces when you follow a thread long enough. The anti-D program in Australia has been remarkably successful. The rates of Rh incompatibility-related infant death have fallen dramatically since the treatment became standard. The protocol of testing every pregnant woman for her Rh status and providing anti-D to those who need it has been integrated into routine obstetric care. The problem that was killing babies in Australian families for the entire colonial period, the invisible biological consequence of who the colonists were and where they came from, has been almost entirely solved. Almost entirely. Not completely. Because the treatment requires access to obstetric care, and access to obstetric care in Australia in the 21st century is still not uniformly distributed. The remote communities that were most underserved in the 1950s and 1960s are still, in many cases, the communities where access to routine obstetric monitoring is most limited. The gap has closed significantly, but it has not closed entirely. And the communities where access remains most limited are, in many cases, the same communities whose blood type data is least well characterized. This is the thread that connects the historical story to the present. The elevated Rh negative rate in Australia is not just a historical fact. It is a contemporary medical consideration that is still being managed, still shaping clinical protocols, still requiring resources and attention. And the management of it is uneven, in ways that reflect the same inequalities that have shaped Australian history throughout the colonial period. The blood tells that story too, if you know how to read it. Now let us go to the south, to a coast that feels very different from the tropics of the territory, to the cold, clear water and the grey-green eucalyptus, and the smell of salt and rock that characterizes the southern fringe of the continent. Because there is a story in that landscape that connects to everything we have been following, a story that involves one of the more unusual episodes in the history of Australian blood type research, and that takes us back into the question of what ancient contact and ancient mixture might have left in the Australian genetic record. The southern coast of Australia, from roughly Albany in Western Australia to Cape Otway in Victoria, is one of the most archaeologically rich regions of the continent in terms of the antiquity and the continuity of Aboriginal Australian occupation. The Mirning and the Ngarrindjeri and the Kulin nations and dozens of other groups have lived along this coast for tens of thousands of years. They developed relationships with the Southern Ocean that were sophisticated and detailed, knowledge systems about its seasons and its resources and its dangers that were accumulated across hundreds of generations. And along this coast, there are also some of the earliest sites of European contact in Australia. Not the 1,788 landings in the east, but the Dutch and Portuguese and later French expeditions that touched the southern and western coasts in the 17th and 18th centuries, decades and sometimes centuries before the British established the colonies that would become the modern Australian states. The Dutch East India Company ships that were crossing the Indian Ocean to the Spice Islands of what is now Indonesia regularly encountered the Australian coast, sometimes intentionally and sometimes not. There were wrecks. There were landings. There were, in at least some cases, extended stays on shore while ships were repaired or supplies were gathered. And the genetic research has suggested, in preliminary ways that need much more work before firm conclusions can be drawn, that some of these contacts may have left traces. This is genuinely contested territory. The evidence is indirect, the interpretation is disputed, and the history of claims about pre-colonial contact between Australia and the outside world is littered with the wreckage of theories that turned out to be more wishful thinking than rigorous analysis. But the DNA doesn't lie, or at least it doesn't lie in the ways that wishful thinking does. And the DNA from some communities along the southern coast of Australia has produced signals that researchers have noted and are trying to understand. Signals that could indicate contact with groups from outside the continent at some point before the formal colonial period. Signals that are too faint and too ambiguous to support any specific historical narrative with confidence, but too persistent to dismiss. Where this intersects with the blood type story is in the possibility that some of those contact events, if they occurred, involved populations with blood type distributions that differed from the local Aboriginal populations, not necessarily populations with elevated Rh-negative rates. The Dutch sailors of the VOC were primarily from the Netherlands and from the maritime communities of Northern Europe, and while those populations do carry Rh-negative at moderate frequencies, they are not among the highest frequency groups in the world. But any genetic mixing, however limited, would have added new variants to the local genetic pool. And over several centuries, even small inputs of new genetic material can affect the frequencies of rare traits in ways that show up in contemporary data if you know what to look for. The point is not that this happened. The point is that we do not know whether it happened, and that the investigation of that question requires the kind of careful, community-engaged genetic research that has not yet been fully carried out in those communities, and may not be carried out in the way it needs to be done for years or decades to come. The southern coast holds its secrets, as the oldest occupied continent holds many of its secrets, waiting for the right questions to be asked in the right way by the right people. In the meantime, the mystery continues. The numbers sit where they sit. The Rh-negative rate in Australia remains higher than in any other Southern Hemisphere country. And the full explanation for why this is true remains, in its deepest layers, just beyond the reach of what we currently know. That is not a frustrating conclusion, or it need not be. It is an invitation to stay curious, to keep following the threads, to resist the temptation of the clean answer when the messy, incomplete, still being worked out truth is so much more interesting. Come further in. We are not done yet. There are moments in Australian history where the blood type story intersects with something much more famous, much more documented, and much more emotionally resonant than blood bank statistics. One of those moments is Gallipoli. On the 25th of April, 1915, Australian and New Zealand troops landed on the Gallipoli Peninsula in what is now Turkey, as part of a British-led campaign to open a supply route to Russia through the Dardanelles. The campaign was a military disaster. The terrain was impossibly difficult. The Ottoman defenders were well positioned and fiercely effective. Within hours of the landing, the plan had broken down, and what followed was 8 months of grinding, brutal, costly fighting that produced enormous casualties and no strategic gain. The Gallipoli campaign became, and remains, one of the most powerful pieces of Australian national mythology. The Anzac legend, the idea of the Australian soldier as resourceful and egalitarian and brave and fundamentally decent, was forged in those Turkish cliffs. Anzac Day, April 25, is now observed as Australia's most significant national commemoration, more attended and more emotionally resonant than Australia Day itself for a significant proportion of the population. What Gallipoli has to do with blood type is, on the surface, a medical question. The campaign produced thousands of wounded men who needed blood transfusions, and the understanding of blood type compatibility in 1915 was still rudimentary and unevenly applied. The British military medical system had begun to incorporate blood typing into its protocols, but had not yet achieved the systematic application that would characterize later conflicts. Transfusion reactions occurred. Some soldiers who might have survived their wounds did not survive their treatment, but the connection to the Australian blood type story goes deeper than that. Because Gallipoli was fought by a generation of young Australian men who were largely the grandsons and great-grandsons of the convict and immigrant population of the 19th century. The men who went to Gallipoli came from the farming communities of Victoria and the Queensland sugar fields and the goldfield towns of Western Australia and the cattle stations of the Territory. They came from families that were, in many cases, Irish Catholic or Scots Presbyterian or Welsh nonconformist. From the same gene pool, in other words, that had been accumulating an elevated Rh negative rate through the accident of colonial settlement. The Army enlistment records from 1914 and 1915 include physical descriptions of the recruits, but not blood types, because routine blood typing was not yet part of the enlistment process. But the demographic characteristics of those recruits, the ethnic breakdown, the regional origins, the family histories, are consistent with what you would expect from a population with an elevated Rh negative rate. These were men from the same families and communities whose women were losing babies to Rh incompatibility in the same decades. There is something poignant about that connection. The same genetic inheritance that made Australian families vulnerable to a particular kind of invisible grief at home was also being deployed on the beaches of Gallipoli, in the bodies of young men who were about to become the foundation of a national mythology that is still being debated and reconfigured and argued over a century later. The Anzac legend has been criticized as a kind of national mythology that has been used to justify wars and to silence dissent and to elevate a particular vision of Australian masculinity at the expense of other stories. Those criticisms are real and they matter. But the men themselves were real too, with real blood types and real families and real histories that connected them to all the layers of Australian history we have been tracing through this night. And the blood that ran in them, and sometimes spilled out of them on those Turkish cliffs, was part of the same story. After Gallipoli, after the First World War, Australia changed. The losses of the war, which were proportionally among the highest of any country that participated, had a demographic effect that researchers have studied, but that is hard to fully quantify. The generation of men who died at Gallipoli and on the Western Front did not have the children they might have had. Their absence from the gene pool was not randomly distributed. The men who enlisted disproportionately came from particular communities and backgrounds. Their absence affected those communities' subsequent demographic development in ways that rippled forward through generations. Whether this had any measurable effect on blood type distributions in subsequent decades is a question that has not been seriously studied. It is the kind of counterfactual that is very hard to address rigorously, but it belongs in the complete telling of this story, as a reminder that human history, including genetic history, is shaped not only by who was present but by who was absent, by the children who were never born because their potential parents died young. The interwar period in Australia was a time of demographic consolidation. Immigration slowed, the country turned inward. And the blood type distribution of the population, which the newly established blood banking system was beginning to document for the first time, reflected the patterns established by the first century of colonial settlement, the British-Irish founding population, the gold rush mixing, the regional variations produced by different immigration patterns in different states. Then came the Second World War and another demographic shift. And then the post-war immigration program, which would bring more people to Australia in a shorter time than any previous wave of immigration, and which would reshape the country's genetic profile in ways that are still being documented. The post-war immigration program began in 1945 under Immigration Minister Arthur Calwell, who famously declared that Australia must populate or perish. The government's target was to increase the population by 2% per year, with 1% coming from natural increase and 1% from immigration. At its peak, the program was bringing 180,000 migrants a year to a country with a total population of around 7 million people. Initially, the program prioritized British migrants, who were offered subsidized passages and preferential processing. But the pool of available British migrants was not large enough to meet the targets, and the definition of acceptable immigrants was gradually broadened, first to include other Northern Europeans, then Southern Europeans, then Eastern Europeans, Italians and Greeks and Poles and Ukrainians and Latvians and a dozen other nationalities began arriving in large numbers, settling in the outer suburbs of Sydney and Melbourne and the industrial towns of New South Wales and Victoria. Each of these groups brought different blood type profiles. The Italian and Greek migrants, who arrived in large numbers in the 1950s and 1960s, come from populations with Rh-negative rates that are close to the European average, somewhat lower than the Irish and British rates that had dominated the previous century of immigration. The Eastern European migrants, Poles, Ukrainians, Czechs, also bring Rh-negative rates in the Middle European range. The net effect of this immigration wave on the Australian Rh-negative rate was, to first approximation, a dilution, a pulling of the national average toward the broader European mean, away from the elevated British-Irish level that the founding population had established. This shows up in the blood bank data from the 1960s and 1970s, which shows the Rh-negative rate in urban Australian populations trending slightly downward from the peaks of the mid-century. But the rate remained elevated relative to the Southern Hemisphere comparison group, because the comparison group, the other countries of the Southern Hemisphere that Australia is being measured against, were not receiving the same immigration patterns. South Africa was receiving European immigration, but dominated by Afrikaner and British populations with their own specific blood type profiles. Argentina and Brazil had large European immigrant populations, but those populations were dominated by Italians and Spanish, not by the British and Irish who had been so central to Australian demographics. So, Australia's relative position? Its distinction as the Southern Hemisphere country with the highest Rh-negative rate was maintained through the post-war period and into the contemporary era, even as the absolute rate shifted with each new wave of immigration. The contemporary Australian population is the most ethnically diverse in the country's history. The immigration of the last 40 years has brought large numbers of people from Vietnam and China and Lebanon and India and the Philippines and sub-Saharan Africa and dozens of other countries. These populations bring blood type profiles that are, in many cases, very different from the British-Irish heritage that established the initial elevated Rh-negative rate. Asian populations, broadly speaking, have Rh-negative rates that are very low, often below 1%. Sub-Saharan African populations similarly. The arrival of large numbers of migrants from these regions pulls the Australian Rh-negative rate downward, toward the global average, away from the historical peak. And yet, current blood bank data still shows Australia above any other Southern Hemisphere country. The legacy of the founding demographic is persistent. It is being diluted, year by year, generation by generation, as the country becomes more diverse, and as the children of more recent migrants are born and grow up and become the next generation of Australians. But it has not yet been diluted to the point where the distinction disappears. How long that distinction will last is a genuinely interesting question. And it is a question that has no political content, no implications about who is more or less Australian or whose heritage is more or less valid. It is simply a question about biology and time, about how long the genetic signature of a founding population persists in the face of ongoing mixing, about what the data will look like in 50 or 100 years when the mixing has had more time to do its work. No one knows the answer, but it is the kind of question that the geneticists who study these patterns find genuinely fascinating, precisely because it connects the deep history to the present and points toward a future that is still being written. We are all, in this sense, participants in an ongoing experiment in what happens when human populations mix. Australia is one of the most interesting current examples of that experiment. And the Rh-negative frequency is one of the clearest, most measurable traces of how the experiment has unfolded so far. The story is not over. It is very much ongoing. But let us go back in time one more time before we begin to bring this night to a close. Because there is one more layer to this mystery that we have not yet fully explored, one that sits in the space between the science and the history and the mythology, And that connects the Australian story to the deepest questions about what Rh-negative blood is and where it came from. The question of the Basque connection. The Basque people sit at the center of every serious attempt to understand the origin and the history of Rh-negative blood. You cannot spend time with this subject without coming back to them, to their language, to their genetics, to the question of who they are and where they came from, and what their extraordinary Rh-negative rate can tell us about the deep history of the trait. The Basque country straddles the border between Spain and France in the Western Pyrenees along the Bay of Biscay. It is a landscape of green hills and rocky coastline and ancient towns, whose names are full of unusual consonants and vowel combinations that give the language Euskara its distinctive sound. The Basques are not a large population. There are perhaps 2.5 million people who identify as Basque, and not all of them speak the language that their identity has historically centered on. But their genetic and linguistic distinctiveness is so pronounced, so thoroughly documented, so resistant to any simple explanation, that they have attracted the attention of researchers from an enormous range of fields. Their language is a linguistic isolate, not in the sense of being unusual or rare, though it is both of those things. In the technical linguistic sense of having no demonstrable relationship to any other known language, living or dead. Every other language in Europe belongs to a family. The Romance languages, French and Spanish and Italian and Portuguese and Romanian, descend from Latin. The Germanic languages, English and German and Dutch and the Scandinavian languages, share a common ancestor. Even the languages of Eastern Europe, Polish and Russian and Czech and the others, belong to the Slavic branch of the vast Indo-European family tree that connects most of the languages spoken between Ireland and northern India. Euskara stands alone. It has borrowed words from Latin and from Spanish over centuries of contact. It has changed and evolved as living languages do. But its fundamental structure, its grammar, its core vocabulary, the bones of it, cannot be connected to any other language family on Earth. Linguists are confident in saying this because they have tried exhaustively and with considerable ingenuity to find the connection. It is not there. The most widely accepted explanation for this isolation is that Euskara, or something ancestral to it, was spoken in Western Europe before the arrival of the Indo-European languages, which linguists now believe spread from the steppes of Central Asia into Europe beginning around 5,000 years ago. The Indo-European expansion was demographic as much as cultural. It brought new populations into Europe, populations that mixed with the existing inhabitants but that also, in many regions, replaced them substantially. The result was the near-total replacement of pre-Indo-European European languages everywhere except in the remote southwestern corner of the continent where the Basques lived. The Basques survived this linguistic tsunami not because they were somehow superior, but because they were in the right place. The Pyrenees provided a degree of geographic isolation that slowed the demographic replacement. The particular combination of mountain terrain and Atlantic coastline that characterizes the Basque country was home to a population that was harder to displace, harder to absorb, harder to linguistically replace than the more accessible populations of the European interior. And crucially, this linguistic isolation corresponds to a genetic isolation that shows up clearly in the DNA data. The Basques are genetically the most distinctive European population, showing the strongest signal of continuity with the pre-Indo-European inhabitants of Europe. They carry, in their genes, a higher proportion of the genetic heritage of the original hunter-gatherer populations that were living in Western Europe before the agricultural revolution and before the Indo-European expansion than any other European population that has been studied. This is why their Rh-negative rate is so high. The mutation that produces Rh-negative blood arose in those ancient European populations, or spread through them to an unusual degree at some point in the deep past that we cannot yet precisely date. And because the Basques have maintained a higher degree of genetic continuity with those populations than anyone else in Europe, they have preserved a higher frequency of the trait. The Celtic populations of the Atlantic fringe, the Irish and Welsh and Scottish Highlanders, who are the next highest frequency groups, are not as genetically continuous with the pre-Indo-European population as the Basques are. They underwent more of the demographic mixing that characterized the Indo-European expansion. But they also maintained more of the ancient European genetic heritage than the populations of continental Europe that received larger and more repeated influxes of incoming people from the East. And when those Celtic populations emigrated to Australia in the 18th and 19th centuries, they brought their genetic heritage with them, including their elevated Rh-negative rates, including the ancient European signal that connects them, however distantly, to the pre-Indo-European populations that the Basques so dramatically represent. Australia's elevated Rh-negative rate is, in this sense, a kind of echo. An echo of a very old European story, of populations that lived in the western fringes of the continent for tens of thousands of years in relative isolation, that developed and maintained a genetic trait whose origin and persistence we still do not fully understand, and that were eventually transported to the other side of the world by the machinery of the British Empire, arriving on a continent that had been home to human life far longer than Europe had, carrying in their blood a mystery that would not begin to be understood for another century. That is a remarkable chain of historical events. Remarkable not because it is unique, because human history is full of remarkable chains of events, but because the blood type data makes it visible in a way that other kinds of evidence do not. The Rh-negative frequency in a contemporary Australian blood bank is a compressed version of this entire story. If you could unfold it, if you could trace it back through the generations, you would travel from the present day in Sydney or Melbourne or Adelaide through the colonial period to the convict ships leaving Portsmouth and Cork, back through the centuries of Irish and Welsh and Scottish history to the Atlantic coastal populations of the medieval and ancient periods, and further back still to the pre-Indo-European hunter-gatherers of Western Europe, who were the first people to carry this particular genetic variant in high frequencies, living in the caves and along the coasts of a Europe that bore almost no resemblance to the continent it would eventually become. That is a long thread. And it ends up by a set of historical accidents that no one planned or intended in one of the youngest nations on Earth, in the blood of the descendants of people who were taken from their homes and shipped across the world in chains, or who left voluntarily in search of something better, or who arrived chasing gold, or who came because the government of a country they had never heard of offered them a fair subsidy and a future. The history that produced Australia's blood type statistics is also, in every detail, the history that produced Australia. The country and the blood are inseparable. The story of one is the story of the other. And the mystery at the center of both, the question of where Rh-negative blood came from and why it persists, and what it means that it is more common here than anywhere else in the Southern Hemisphere, is a mystery that opens outward into the biggest questions about human history, about who we are and where we came from, and how the accidents of geography and migration and colonization and biology combine to produce the world as it currently exists. These are not small questions. They are among the most interesting questions any of us can spend time with. And this night, in whatever room and whatever city or town or countryside you find yourself in, is as good a time as any to sit with them. The answers are not complete. They may never be complete. But the asking is valuable in itself. The curiosity is valuable in itself. The willingness to follow a thread from a number in a blood bank registry all the way back through 70,000 years of human history, through ice ages and ocean crossings and colonial ships and gold fields and genetic sequences that are still being read, is valuable in itself. It is what the species does. We ask, we look, we try to understand. The fact that we cannot understand everything yet does not make the trying less worthwhile. It makes it more so. Let us continue. There is something that has been building in the background of this entire story that we have not yet fully addressed. Something that sits in the space between the scientific and the personal, between the population level statistics and the individual lives that those statistics are made of. Something that a significant number of Australians are aware of about themselves, who know their own Rh-negative status, and who have thought about what it means. Because Rh-negative status is not just a medical designation. For many people who carry it, it has become something more than that. A piece of self-knowledge that feels significant, that connects to questions about identity and heritage, and what the body carries that the mind does not always know about. This is the terrain we need to walk through carefully, because it is where the genuine science and the genuine personal experience meet a body of speculation and mythology that ranges from the harmlessly fanciful to the genuinely misleading. And, in Australia specifically, where the history of blood and identity and racial classification has been so freighted with violence and injustice, it requires particular care. Every year, a meaningful number of Australians discover for the first time that they are Rh negative. The discovery happens in different contexts. Sometimes it is in a doctor's office, during a routine health check that includes a blood panel. Sometimes it is when a woman is tested for her blood type during her first pregnancy, which is standard obstetric practice. Sometimes it is when a person donates blood for the first time and receives a card telling them what type they are. And sometimes, in the present era, it arrives through a commercial ancestry and health testing kit that also provides information about blood type markers. Whatever the context of the discovery, the reaction is often the same. A moment of mild surprise, because most people have not thought about their blood type in any detail, followed by a period of curiosity, and then, often, a search for what it means. That search leads, in the present day, inevitably to the internet. And the internet provides an enormous amount of information about Rh negative blood of extremely variable quality. At one end of the quality spectrum, there is the legitimate scientific literature, papers in genetics journals, blood bank research reports, public health studies. This material is accurate and careful and often genuinely interesting, but it is also technical and hedged with the appropriate caveats of scientific writing, and it does not tend to show up at the top of search results when someone types, "What does it mean to be Rh negative?" What shows up at the top of those search results, instead, is a world of claims about Rh negative people being empathic and intuitive and resistant to certain diseases and possibly of non-human ancestry. Websites and YouTube channels and Facebook groups that have built communities around the shared identity of being Rh negative that treat the blood type as a meaningful category of personal identity rather than simply as a medical characteristic. These communities are, it should be said, often warm and supportive and genuinely fun for their members. The experience of discovering you share something unusual with a group of people and finding community around that shared characteristic is a very human experience. And many of the people in these communities are not committed to the more extreme claims. They are curious people who found something interesting and are exploring it in the company of other curious people. But the claims themselves, the specific claims about what Rh negative blood means for personality and ability and ancestry, are not supported by the science. The personality correlations that various websites assert, the idea that Rh negative people are more likely to be empathic or intuitive or prone to certain kinds of creativity, are not documented in any peer-reviewed research. The health claims, beyond the well-documented pregnancy issue and the transfusion compatibility considerations, are not robustly supported. And the ancestry claims, particularly the ones that involve extraterrestrial origins or hybrid genetics, are not just unsupported but are actively in conflict with what we know about human genetics. None of this prevents the claims from being appealing. Appealing ideas do not become true by virtue of being appealing, but they do become persistent. And in Australia specifically, where the Rh negative rate is genuinely elevated above the Southern Hemisphere norm, and where the history of the country provides genuinely interesting explanations for that elevation that connect to Celtic and pre-Indo-European European genetics, the appeal of the claims is perhaps stronger than it might be in countries where the Rh negative rate is less notable. There is a subgroup of Australian Rh negative identity discourse that takes the Celtic connection seriously and in interesting ways. The idea that an elevated Rh negative rate in Australia connects the country's population to the ancient genetic heritage of the Celtic fringe of Europe is not wrong, in the sense that the connection is demographically real. It is not a mystical connection. It is a straightforward consequence of who the colonists were and where they came from. but it can be presented in ways that are thoughtful and grounded in genuine history, exploring the Celtic cultural heritage that is part of Australian history, the Irish convict experience, the Scottish pastoral contribution, the Welsh mining communities of the coalfields, and connecting that heritage to a genetic characteristic that the Celtic populations carried with them. This kind of exploration, when it is careful and accurate, is genuinely valuable. It is a way of taking seriously the specificity of Australian ancestry, kind of understanding the country not as a generic extension of British culture, but as a place where particular populations with particular histories arrived and mixed and created something new. The problem comes when the Celtic connection is used as a launching pad for claims that go beyond what the evidence supports. When the genuine mystery of Rh-negative blood's origins in pre-Indo-European Europe is inflated into claims about special abilities or non-human ancestry. When the very real historical suffering of Celtic populations, the Irish famines and the Scottish clearances and the Welsh enclosures, is romanticized in ways that serve a narrative of special victimhood rather than genuine historical understanding. The history does not need to be inflated. It is already extraordinary on its own terms. The real story of how a genetic trait that developed in ancient European populations, possibly in the cave-dwelling hunter-gatherers of the Western European Atlantic coast 20,000 or 30,000 years ago, ended up elevated in an isolated nation in the Southern Hemisphere through the mechanisms of colonial transportation and voluntary immigration and gold rush chaos, is more interesting than anything the mythology has to offer. It is also true, and worth saying explicitly, that the experience of many Rh-negative Australians, of discovering they carry a relatively rare blood type and feeling that this connects them to something larger than themselves, is a real experience. The feeling is real, even if the specific claims built around it are not always accurate. Human beings are meaning-making creatures. We look for ways to understand ourselves in relation to something larger, whether that is a community or an ancestry or a history or a religion or a blood type. The impulse is completely understandable, and it is not inherently harmful. What matters is whether the meaning we make is grounded in what is actually true, or whether it drifts away from the truth in directions that end up obscuring rather than illuminating. In the case of Rh-negative identity communities, the drift away from the truth tends to obscure the genuinely interesting real story in favor of a more dramatic but less accurate one. And in Australia specifically, where the real story is so deeply connected to the specific history of the country, that obscuration is a genuine loss. The real story is about convicts and colonists and goldfield workers and women who lost babies to a mechanism no one understood. It is about the Basques and the Celts and 20,000 years of European genetic history. It is about a continent that has been home to human life for 65,000 years and that is still trying to understand its own complete genetic history. It is about the development of a medical treatment that ended a particular form of suffering that had been running through Australian families for 2 centuries. These are stories worth knowing, worth following, worth sitting with in the dark on a night when you want something that carries weight and takes you somewhere you have not been before. They are better than the mythology. Not because mythology is not valuable, because human beings need myth as much as they need fact, but because in this case the truth is genuinely more interesting and more complex and more moving than the myth that has grown up around it. The myth offers a simplified specialness. The truth offers something deeper, a connection to the full, messy, extraordinary story of what humans have done on this planet and to each other and to themselves. That story includes Australia's blood type statistics. And Australia's blood type statistics, read carefully and in context, illuminate the story in return. We are almost at the end now, but not quite. There is one more thread to follow. One that takes us to the present day and to the question of what comes next, what the future holds for the biological and the social and the historical story that we have been tracing through this night. Because the story is not finished, it is ongoing, and some of the most interesting chapters may be the ones that are still being written. In a laboratory at the University of Adelaide, there is a research project that has been underway for several years now that is slowly and carefully attempting to fill in some of the gaps in the Australian genetic story that we have been circling throughout this night. The project is working with ancient DNA extracted from archaeological sites across the continent in collaboration with Aboriginal community organizations that have agreed to participate on terms that give them meaningful control over how the data is used and how the findings are interpreted and shared. The technical challenges of this work are formidable. Ancient DNA extraction in Australian conditions requires approaches that were developed specifically for environments where the usual conditions that favor DNA preservation, cold and dry and stable, are largely absent. The researchers working on this project have had to innovate in ways that are producing methods and findings that are contributing to the broader field of ancient genetics even beyond the Australian context. The early results, shared cautiously and in consultation with the community partners, are beginning to paint a picture of Australian prehistory that is more complex than the isolation model suggested, and that is consistent with, though not yet fully confirmatory of, some of the patterns in the contemporary genetic data that Carroll was trying to make sense of 4 decades ago. The 4,000-year-old contact event, the arrival of new populations and new genetic material in Australia around that time, is being documented with increasing precision. The sources of that contact, where exactly the incoming people came from, what their relationship was to existing Australian populations, how long the mixing continued, and how far into the continent it penetrated, these questions are being addressed with a level of detail that was simply impossible before the current generation of ancient DNA tools. And some of the findings are producing what researchers in this field privately describe as extremely interesting results. Results that do not yet support any specific revisionist narrative, but that are sufficiently unexpected that they are prompting reconsideration of some assumptions that had been held with considerable confidence. The question of blood type distributions, specifically, is not the primary focus of this research. Blood type antigens are encoded by genes, and those genes can in principle be detected in ancient DNA, but the work required to do so reliably in fragmentary ancient samples is different from, and in some ways more demanding, than the population ancestry work that is the main focus. But the population ancestry findings have implications for blood type distributions because you cannot have a new population arriving and mixing with an existing one without also introducing some of the incoming population's genetic variants, including potentially rare variants like the one that produces Rh-negative blood. Whether any of the populations involved in those ancient contact events carried Rh-negative blood at frequencies high enough to matter is not known. The direct evidence does not yet exist. But the indirect evidence, the demographic evidence, the population genetics evidence, is beginning to suggest that the story is complicated in ways that the standard model did not anticipate. And complicated in this context means interesting. Means that the picture that will eventually emerge is likely to be more nuanced, more layered, and more surprising than the clean story of 65,000 years of isolation followed by European colonization. This research is slow. It is careful. It is being done in ways that prioritize the rights and the interests of the communities whose ancestral remains and whose living genetic heritage are involved. It will be years before any of the specific questions we have been asking tonight can be addressed with the kind of precision that would allow firm conclusions. But it is happening, and the trajectory of it is toward a fuller, more complete, more honest picture of what happened on this continent before the colonial period, and what those ancient events mean for the genetic makeup of contemporary Australians. Meanwhile, the blood banks continue their work. Every day, across Australia, people donate blood. Some of them are O-negative, the universal donor type, whose donations are particularly valuable for emergency situations where there is no time to determine a recipient's blood type. Some of them are Rh-negative with other blood types, whose donations are essential for other Rh-negative patients who need transfusions. The Australian Red Cross Blood Service tracks these donations, monitors the supply of Rh-negative blood, and works to ensure that the supply meets the need. The need is specific and ongoing. Rh-negative blood cannot be replaced by Rh-positive blood for Rh-negative patients without risk. The elevated Rh-negative rate in Australia means a higher demand for Rh-negative blood than comparable countries in the Southern Hemisphere, which means the supply pressure is correspondingly higher. And because O-negative blood in particular is so critical for emergency medicine, the maintenance of an adequate supply is a genuine public health consideration. The people who donate O-negative blood in Australia are, in a very real sense, the inheritors of the story we have been tracing tonight. Their blood type is the product of the colonial history and the Celtic heritage and the British-Irish founding population and the gold rush and the post-war immigration program and the specific accidents of who met whom and had children together over 2 centuries of one of the most dramatic demographic histories any continent has ever experienced. When they walk into a donation center and sit in a chair and give a unit of blood, they are participating, without necessarily knowing it, in a story that goes back through their own family history and through Australian history and through European history and through the deep prehistory of the continent, all the way to the pre-Indo-European populations of ancient Western Europe. That is a remarkable thing to carry in your blood. It is remarkable even if you do not know you carry it, even if the knowledge of the story has never reached you. Even if the only thing you know is the letter on your blood donor card. The blood carries the story whether or not the person knows the story. That is what makes genetics so fascinating and so strange. The information is there, encoded, persistent, passed from parent to child through every generation, completely indifferent to whether anyone is paying attention or not. It waits for the question to be asked and for the tools to exist to read the answer. In Australia, the question is being asked with greater sophistication than ever before. The tools are better than they have ever been. And the story that is being read, slowly and carefully and with increasing precision, is one of the most complex and layered and genuinely surprising stories in the history of the species. That is not a story about aliens or ancient mystical bloodlines or special powers conferred by the absence of a single protein. It is a story about human beings moving across the surface of a planet over tens of thousands of years, meeting and mixing and creating new populations that carry genetic traces of all the meetings that produce them. It is a story about the accident of colonial history, creating a demographic situation that expressed itself in blood bank statistics a century later. It is a story about the bodies of women and the grief of families and the slow, imperfect, ultimately remarkable progress of medical understanding. It is a story about what it means to be human in a particular place at a particular time, carrying in your blood the compressed history of everywhere and everyone who came before. It is, in the end, your story too. Whatever your blood type, whatever country you find yourself in, whatever time it is where you are right now. Because you carry a version of this story in your own blood, in your own genes, in the particular combination of inherited variants that are uniquely yours. The particular path that history took to produce you, the specific migrations and mixings and accidents of birth that led to your parents meeting and to you being born in the body you inhabit, that path is encoded, at least in part, in your DNA, including, if you carry it, in the presence or absence of a single protein on the surface of your red blood cells. The mystery is in everyone's blood. Australia's version of it is simply more visible, more documented, more persistently above the Southern Hemisphere baseline than anywhere else in this part of the world. And that visibility is what makes it worth spending a night with, worth following the threads all the way back to the beginning, worth sitting with the questions that do not have complete answers, worth listening to the story that is still being told. The southern stars are out, somewhere above you, whether you can see them or not. The land beneath wherever you are is old, in the way that all land is old, carrying its own compressed history in stone and soil and the slow movement of deep time. And somewhere in that history, in the migrations and the losses and the arrivals and the departures that shaped the human world as it currently exists, is the explanation for what the blood banks in Australia show. Not complete, not final, but present, waiting to be read a little more clearly with each passing year. Let that thought settle. We are not done. There is one final thread, the oldest and in some ways the most mysterious, and it connects the very start of this story, 70,000 years ago on the edge of Africa, to the present moment, in a way that asks a question about the deep future as well as the deep past. Stay with me a little longer. There is a detail of the Australian gold rush that the history books mention briefly and then move past, because it does not fit neatly into the heroic narrative that the gold rush prefers for itself. The detail is this. When gold was discovered in Victoria in 1851 and the world began pouring into the colony, one of the groups that arrived in substantial numbers was women, not just the wives and sisters of male prospectors. Women who came on their own account. Women who had been living in circumstances in Britain and Ireland and Europe that offered them very little, who heard that in the chaos of the goldfields the usual rules were temporarily suspended, that a person with determination and a willingness to work in conditions that most people would refuse might find something different on the other side of the world. Some of these women did find something different. Some of them found themselves keeping boarding houses in Ballarat or Bendigo that were profitable enterprises, catering to the thousands of men who needed somewhere to sleep and eat. Some of them worked as cooks and laundresses and in the small businesses that sprang up around the goldfields to serve the influx of population. Some of them married miners who struck it rich and found themselves, for a few extraordinary years, in possession of a material comfort they had never imagined could belong to them, and some of them died. In childbirth, in the goldfield conditions, far from any hospital, attended only by whoever happened to be nearby. In those deaths, in those labours that did not go well, in those babies who were born pale and did not thrive, the invisible biology of blood incompatibility was operating in the background of a story that the historical record has preserved only partially and imperfectly. The women who survived the goldfields, who raised children in the rough timber houses that replaced the canvas tents of the first years, who watched their communities slowly acquire the infrastructure of permanence, churches and schools, and eventually hospitals, those women were the foundation of the Victorian and New South Wales population that would carry the elevated Rh- rate forward into the 20th century. Their blood was in their children and their grandchildren and the generations that followed, in the suburbs and the farming communities and the industrial towns, and eventually the cities that replaced the goldfields as the centres of Australian life. The gold rush created Australia in a demographic sense. It turned a convict colony into something that looked more like a country. And the particular mixture of people it brought, the Irish and the British, and the smaller contingents of Europeans and Chinese and others, created the genetic profile that the blood banks would document a century later. But it also created something else. It created a culture of movement, of willingness to pull up roots and go somewhere completely different in search of something better. That culture of movement persisted in Australian life long after the gold ran out. It expressed itself in the willingness of Australians in the 20th century to emigrate to cities when the farms dried up, to move to other states for work, to be more geographically mobile than many comparable populations, and it expressed itself in the openness to immigration that, however imperfect and however contested the politics of it have been, has made Australia one of the most ethnically diverse societies in the world. That diversity is now part of the blood type story too. Not in the way that the founding population is part of it, not as the source of the distinctive elevated frequency, but as the ongoing process of mixing and change that will eventually, over generations, normalize the Australian blood type distribution toward the global average. The dilution that has already been happening since the post-war immigration program is continuing, wave by wave, generation by generation, as the children and grandchildren of more recent arrivals are born and become Australians whose blood reflects the full complexity of where they come from. This is not a loss, it is a change. The particular distinction that makes Australia notable in the Southern Hemisphere blood type tables is a consequence of a specific and unrepeatable historical moment, the colonial settlement by a population weighted toward the highest Rh- groups in the world. That moment is past. The consequences of it persist, but they are slowly being diffused into the larger story of a country that has become something far more complex than what it was in the first decade after 1788. The Australia of the 21st century is a country of extraordinary ethnic and cultural diversity, in which the British and Irish founding population is still demographically significant, but is no longer the only story, and in which the genetic history of the country is genuinely plural in ways that are still being understood. The blood type statistics will continue to change as the demographic mix changes. In 50 years, in 100 years, the elevated Rh negative rate may have narrowed to the point where it is no longer a notable distinction, or it may persist longer than the demographic models predict, because the genetics of founding populations can be surprisingly durable, showing up in descendants for many generations after the initial mixing has occurred. We will see. The data will be collected and analyzed, and the picture will become clearer over time, as it has been becoming clearer for decades, as each new generation of tools and each new set of research questions adds another layer of understanding to the accumulated record. And somewhere in that record, somewhere in the data that is still being gathered and the research that is still being conducted and the archive that Carol began in the 1970s and that others have been adding to ever since, the full story of Australian blood type history is slowly being told, not by any single researcher or any single paper or any single finding, but by the collective accumulation of careful work over time, in the way that the best scientific knowledge is always accumulated, patient, incremental, occasionally surprised by what it finds, always more interested in what is true than in what would be convenient or dramatic or satisfying. Always willing to revise when the evidence requires revision. That is the science. And it is doing its work, quietly, in laboratories and archives and field sites and community consultation meetings across Australia and around the world. The mystery is being worked on. The answers are getting better. And the questions that cannot yet be answered are being identified with increasing precision, which is itself a form of progress, because you cannot answer a question you have not yet been able to ask clearly. This is where the story is right now. Not at the end. Very much in the middle. With the most interesting chapters still ahead, that is enough to know for tonight. More than enough. The middle of a good story is a fine place to rest. The continent is ancient beneath you. The blood is moving through you. The stars are out somewhere above the cloud or the city light or whatever is between you and them tonight. Sleep well. The mystery will still be here in the morning. It has been here for 70,000 years. It can wait a few more hours while you rest. There is one thing more worth saying before this section closes, before the narrative moves toward its final quiet resolution. The blood type story of Australia is also, in a way that does not always get acknowledged, a story about what nations choose to remember about themselves and what they do not. Australia has been working for decades, imperfectly and with considerable resistance from some quarters, but persistently, to come to terms with the full complexity of its history. The colonial dispossession of Aboriginal people, the stolen generations, the White Australia policy that restricted immigration until the 1970s. These are not comfortable histories, but they are real ones, and the willingness to engage with them honestly is part of what determines whether a nation understands itself or only the version of itself that is easiest to live with. The blood type story is a small part of that larger reckoning. The elevated Rh negative rate that Australia carries is a product of the colonial history, of the particular populations that were transported and migrated and settled here. The suffering that rate produced in the bodies of Rh negative women and their Rh positive babies is part of that history too. Acknowledging it does not make the colonial period more or less defensible. It simply makes it more fully known. There is a question that underlies every conversation about Rh negative blood, one that the science has not yet fully answered and that sits at the center of the biological mystery rather than at its edge. The question is not about where Rh negative blood is most common, or what the colonial history produced, or what the blood bank statistics show. The question is much simpler and much harder. Why does Rh negative blood exist? Not in the sense of what genetic mechanism produces it. That is understood. The RHD gene that encodes the Rh protein is deleted or inactivated, and the result is an individual whose red blood cells do not carry the protein. The mechanism is clear. What is not clear is why that mutation persisted, why it spread, why it reached 30% and above in certain isolated populations, rather than being steadily reduced by the selection pressure created by the pregnancy incompatibility. There are several candidate explanations, none of them fully established. The most widely discussed is the disease resistance hypothesis. The idea is that Rh-negative individuals have some immunological advantage against certain pathogens, an advantage that more than compensates for the reproductive disadvantage imposed by the pregnancy complication. Several specific pathogens have been investigated. Toxoplasma gondii, the parasite carried by cats and associated with behavioral changes in infected individuals, shows some differences in how it affects Rh-negative versus Rh-positive individuals in studies that are intriguing but not conclusive. Certain viruses have been investigated with similarly preliminary results. The fundamental problem with the disease resistance hypothesis is that no one has yet identified the specific pathogen and the specific protective mechanism with sufficient rigor to make the case compellingly. The evidence is suggestive rather than definitive. It points toward the idea that there is something there without quite demonstrating what it is. The second major hypothesis is the genetic drift hypothesis. This says, in essence, that the high frequency of Rh-negative in certain populations is not a consequence of selection at all, but simply of chance. In small, isolated populations, rare genetic variants can drift to unusually high frequencies just by the mathematics of small numbers. If the pre-Indo-European populations of Western Europe went through periods of significant population reduction through ice age pressure or disease or conflict, the survivors could have carried a higher than average frequency of Rh-negative by chance, and subsequent expansion of those survivors could have locked in the elevated frequency for thousands of subsequent generations. This hypothesis has the advantage of not requiring any specific advantage for Rh-negative carriers. It explains the elevated frequency as a neutral or mildly disadvantageous trait that got lucky. The Basque people, as the most genetically isolated population in Europe, would represent the most extreme example of this process, having maintained the frequency that resulted from the ancient bottleneck more faithfully than any other European population. The problem with the pure drift hypothesis is that it requires very specific population history scenarios to produce frequencies as high as those found in the Basque country. 30% is a lot for a trait that has a measurable reproductive cost. The drift hypothesis works better for explaining frequencies in the 15 to 20% range that characterize most of the elevated populations than for explaining the extreme Basque case. The third hypothesis is the most speculative and the most interesting, at least from the perspective of what it would mean if it were true. This hypothesis suggests that the Rh-negative trait provides some advantage in early childhood immunity that has nothing to do with the pregnancy complication, and that the early childhood advantage more than compensates for the reproductive disadvantage. The mechanism proposed involves the way in which Rh-negative individuals' immune systems respond to early infections, a slightly different profile that might confer better survival through the critical early years of life in historical disease environments. The evidence for this hypothesis is even more preliminary than for the others. It exists largely as a theoretical framework supported by a handful of suggestive findings that have not yet been replicated at scale. But it is taken seriously by some researchers precisely because it would explain both the persistence of the trait and the geographic distribution. If certain disease environments in Western Europe happen to favor this particular immune profile in ways that made it worth maintaining despite the pregnancy cost, none of these hypotheses is established. All of them remain, in the careful language of science, speculative frameworks requiring further investigation. The honest answer to the question of why Rh-negative blood exists at the frequencies it does is that we do not fully know. And in Australia, sitting as it does at the top of the Southern Hemisphere Rh-negative frequency table, this question has a particular resonance. Because if the disease resistance hypothesis eventually turns out to be correct, and Rh-negative blood does provide some advantage against a specific pathogen or class of pathogens, then Australia's elevated Rh-negative rate would mean something more than just a demographic artifact of colonial history. It would mean that a higher proportion of the Australian population carries whatever immunological advantage the trait provides. This is deeply speculative, to be clear. We are in the territory of if this is true, then this follows. And the first part of that conditional remains very much unresolved. But It is speculative in the way that genuinely interesting science is sometimes speculative before the evidence catches up with the hypothesis. It is worth sitting with the possibility that the story we have been telling tonight, the story of how Irish and British genetic heritage came to be overrepresented in the Australian founding population and produced an elevated Rh negative rate in the Southern Hemisphere's newest nation, might turn out to have a chapter we have not yet read. A chapter in which the elevated frequency matters for reasons that are biological as well as historical, in which the accident of colonial demography turns out, in retrospect, to have had biological significance that nobody at the time could have anticipated. We do not know if that chapter will be written. We do not know if the disease resistance hypothesis will pan out. We do not know what the next generation of immunological research will find about the specific biological effects of carrying or not carrying the Rh protein. But we know that the question is real, that the researchers asking it are serious, and that the answer, whatever it turns out to be, will add another layer to an already extraordinarily layered story. That is what makes this mystery genuinely alive. Not just historically interesting, not just genetically curious, but alive in the sense of still unresolved, still generating new questions, still pointing toward answers that have not yet been reached. There is a road in the outback of South Australia, somewhere between Port Augusta and Coober Pedy, that runs through a landscape so ancient it looks like the surface of another planet. Red rock and white salt, and the occasional ghost of a dried river channel that has not seen flowing water in a very long time. If you drive that road at night, and the sky is clear, which it usually is, because there is no light pollution for hundreds of kilometers in any direction, the stars are overwhelming. More of them than you thought there could be. The Milky Way, not as a faint smear, but as an actual structure, a river of light overhead that you can feel the depth of. The people who have lived in that landscape for tens of thousands of years, the Arabana people and their neighbors, have names for things in that sky that no European language has words for. They have been watching those stars and telling stories about them for longer than any other astronomical tradition on the planet. Their knowledge of the southern sky is detailed and ancient, and carried in oral traditions that encode both mythology and practical information, seasonal markers and navigational guides, and warnings and celebrations, all woven together into a body of knowledge that is still being understood by the wider world. Those same people have been living on land that the geological record dates to the oldest exposed rocks in the country. They have seen the climate change drastically over the millennia of their occupation. They have seen lakes fill and dry and fill again. They have hunted megafauna that no longer exist. They have adapted to conditions that would have ended the presence of a less resilient and less knowledgeable civilization in a fraction of the time. And they carry in their blood a genetic history that is still being mapped. That is connected to the 4,000-year contact event and to whatever happened in those 65,000 years before that, and to the ancient African populations that their ancestors descended from, and to the deep migration that brought the first humans to this continent before the rest of the non-African world had been reached. Whatever blood type they carry, in whatever frequencies, is part of the full Australian blood type story. The part that is hardest to read and that requires the most careful and respectful and patient work to understand, but a part that is real and present, and that the passage of time and the improvement of scientific tools is making more legible. The mystery of Australian blood is ultimately the mystery of Australian history, which is ultimately the mystery of human history. All of those concentric circles of question and context and complexity, all of them real, all of them connected, none of them fully resolved. That is what we have been sitting with tonight. That is what the blood bank records, and the ancient DNA studies, and the hospital archives, and the convict transportation records, and the burial ledgers, and the Goldfield diaries, and the 1980s research notes, and the contemporary genetic research all point toward. Not an answer. An investigation. Not a conclusion. A continuing. The stars over the Australian outback are still out. They do not care about the mystery. They shine with the same indifference that they have been shining with since before there were any human eyes to look at them. But there are human eyes looking at them now, from across Australia and from wherever you are listening to this. And that looking is what we do. That is the species. We look and we ask and we try to understand and we pass the questions on to the next generation when we have not been able to answer them ourselves. The Rh negative rate in Australia is a small part of that enormous project. A specific, measurable, documentable, still only partially explained fact about the biology of a specific population in a specific part of the world. But follow the thread, and it takes you everywhere. That is what biology does, when you let it. When you stop treating it as just a number and start treating it as a story. It takes you all the way back, and all the way forward, and into the full depth of what it means to be a human being, carrying the compressed history of the entire species in your blood, living for a moment in a particular body, in a particular place, at a particular time, asking the questions that all humans ask when they look up at a sky full of more stars than they can count. Where did we come from? What does our blood remember that we have forgotten? What are we still to find out? We are still finding out. We will be for a very long time. And the finding out is one of the most purely human things we do. The room is quiet now. The stars are turning. Whether you can see them or not, the ancient land is under your feet, somewhere, carrying its own deep time, indifferent and magnificent. And somewhere in your blood, your own small piece of this story is moving through you, cell by cell, quiet and persistent, carrying whatever the long history of your own particular ancestors left in you on the red surfaces of the cells that keep you alive. Let that be enough for tonight. Let the questions stay open, because open questions are where the most interesting things live. Let the mystery continue, because the mystery is not a frustration. It is an invitation. And let yourself rest now. The investigation will still be there tomorrow. The ancient land will still be there. The stars, the same ones that the first Australians navigated by, the same ones that the convict ships sailed under, the same ones that the gold rush prospectors slept beneath in the outback, will still be there. For now, you have followed this thread as far as it goes tonight. You have traveled from an African coastline 70,000 years ago to the blood banks of contemporary Australia, through ice ages and ocean crossings and colonial ships and gold fields and medical discoveries and ongoing genetic research. You have sat with a mystery that is real and old and not yet fully resolved. That is enough. More than enough. If this journey has stayed with you, if the questions have been good company in the dark, you can tap like so that the algorithm knows to show you more of this kind of thing. Leave a comment if you want to. Tell me where in the world you are right now, what city or country or landscape is outside your window or invisible in the dark. I always read the comments, and there is something that never stops being interesting about seeing all the different places people are when they listen to things like this. If you would like to come back for more nights like this one, you can subscribe, and I will be here with another long journey into something old and strange and still only partially understood. And if you would like to support this kind of work more directly, there is a membership option on this channel. It is entirely optional. Whether you join or not, these stories will keep being told. But if you find value in them, the membership helps make more of them possible. For now, though, there is nothing you need to do. Somewhere beneath you, the deep rock of wherever you are is carrying its own ancient history. The air around you is the same air that humans have been breathing since before they were fully human. And whatever blood moves through you, whatever particular combination of proteins and antigens and inherited variants that you carry from all the people who came before you, it is doing what blood does, moving, circulating, carrying the oxygen you need and the story you did not choose and the mystery that no one has yet fully solved. Rest now. The southern stars are out. The ancient land is patient. The mystery continues. And you have been part of it for this small piece of the long night in exactly the right way. Good night.